multiple. I guess I could also throw myself up on kick, but I don't like this mix. I don't know, this is getting a little too much. Let me find a better DJ Shadow mix. Why is my scroll broken? Suddenly my scroll is going like that. It's going up and down. That's so weird. Let's see. There we go. Mouse wheel needs to be cleaned. Yeah, that might be it. This computer is indeed getting old. All right, mute that, and then let's put that into its own window. Pop out chat, and then I can close that. All right, there we go. Jeez, I need to automate more. Believe it or not, I need to automate more. I need more automation in this shop. I need to do that window organizing thing so that when I hit the button, everything just gets me completely ready to stream and I don't have to think about stuff, because otherwise I miss things. So yeah, I gave this thing 2 cores and 1 thread. I guess it didn't really even need that. And that was to run something that is Docker. I'm still not clear on exactly how to run Docker. I don't think it's a command line thing. I think I actually need like a desktop in order to do that. And I would like to, for most of these things, to remain kind of command line. You know, like Node-RED has its interface, but I would rather the virtual machines be kind of like Raspberry Pis. I don't know if I can do that with Ubuntu maybe. And then I can have a minimal operating system that can run the small things that will help me recuperate all of my automations, basically. Oh, what is this? This is an old window here. Hold on. I just found a very old window that I need to close down, I think. Which one is this? This one's Twitch and Streamlabs. Log in with Twitch. I hate that I didn't move off of Streamlabs when all that controversy came out. TubeBender, close that. Gigahertz Radio, close that. And then we've got those 2 windows. How's my YouTube channel doing? How are we doing over here? Hold on a sec. Purchase and membership, your data in YouTube. Where's my like creator stuff? Oh, I guess it's these on the left. Yeah. My videos. Now the VODs, I haven't put any of them up lately, but 500 views. Oh, that was an old one. It probably wasn't the last one. Oh no, that's the last one that went up. How'd that get 500? 1,000? 2,000? Holy shit. Dude, it's pretty cool. 2,167 videos for, oh, the ghost hunting thing. That's when we eventually, after that one, yeah, here's the teardown, the further teardown. Only 34 people made it to the 34, the one that 34 people watched, that's when I actually get smart. That's when it's actually smart. The other ones wasn't smart. Oh, and then 20 for the backup power supply. I'm sorry, they all can't be bangers. Hey, what's up, Flatulent Gunhead? How you doing? I'm wrestling TrueNas still, so none of my automated stuff is automated. So I've been looking at stuff like if I want to run a bunch of virtual machines, I would need a virtual machine for the MQTT broker. And then Node-RED, I have it an app, which I've fully restored all of my stuff. It's all here. I need to delete this flow. There we go. Wow, that was easy. They made it very easy to delete that flow. But all of these have wrong config because there's no MQTT broker right now. I need to remember what I did in order to set that up. So like, I guess MQTT broker is not going to need a whole lot of stuff because it's just going to run like Mosquito or something like that. I don't remember anything about it. I know it's not difficult, but when you don't know what you're doing, it's tough. When you're as dumb as I am. What is my most viewed YouTube video? It is the teardown for the ghost stuff. But that's not the smart one. That wasn't very smart. Oh, and then the car computer. When I made a hot knife and it was hot garbage. It was hot garbage. It was not good. Stainless steel does not like conducting heat. So I spent 75 bucks. And then the wheel, one of the wheel streams. Ah, cool. All I have to do is build a giant life-sized using real car parts wheel every single day to get my YouTube fame. Some people get this many views per video. Actually, you know what? The views would be much inflated if I split these up. But if I split them up, it would take me 4 years to upload all of the content. So I did it this way, and then I'm going to cut them around and make sure that I make them good. The MSC logo probably boosted clicks. It's true. It's true. I mean, most of, like, if you look at the top ones, MSC logo, picture of a computer, picture of a circuit board with a keyboard, and a smiling face. It's real manipulative what you can get away with in this fucking environment. Picture of a factory. 400, huh? No restrictions on that one. Hey, one of the few satisfactory ones when I didn't have a copyright bit. Why does the scroll wheel so bad? Am I gonna have to just like order a new mouse? It's double tapping the button when I scroll. What's the viewer retention look like? I don't know. How do I look at that? Get out of here. $4,000 views in the last 28 days. I think that means that I can actually like monetize this. I got muted a bit on stream for an artist and tune I've never heard of. I wasn't even playing music, I was talking. It's getting bad out there, isn't it? I mean, like, the one guy, like, on his hard drive, they used, I want to say AI. They algorithmically, you know, it's everything, chat. Everything is an AI. Everybody just wants to use that word. They algorithmically made every single melody you could possibly make, and they put it on a 2 GB hard drive, and it's basically like any song that gets produced can then be sued by this person. Any 4/4 pop song can get sued. Content. Average view duration, 4 minutes, 2 minutes, 10 minutes. Okay, a little bit better for the teardown. 5 minutes, 1 minute. Jesus. Nobody stuck around with that one. Oh. Yeah. They clicked into the video and fuck that. Jeez. Yeah, nobody watches my videos. What does that even mean? Busted. When did it wait? Busted Tunes. Did you change your screen name? Twitch put ED209 in charge of music claims? Yeah, really. If you hum a melody, you can get in trouble. It's ridiculous. I should copyright me just talking and see if I can find anybody. Like, yeah, give me that revenue. Browse features. Director unknown, other YouTube, channel pages, suggested videos, 0.4. Ugh. I don't know, none of this stuff is meaningful because it's such a small channel. Yeah, it's all the music companies. It's all companies being asswipes. Yeah, exactly. The music shouldn't... my music doesn't go anywhere. Like, the music that I'm playing right now shouldn't be going anywhere. But it's... apparently, they got you off of your voice, which is crazy. This is the kind of work that I do on these streams, by the way. Oops, hold on. Details. I have to go through the video minute by minute and figure out what I was doing. Why is this so dog shit to load? You know why it's so hard to load? It's trying to load the whole video, so it bogs itself down if I click too many things. But yeah, look at all that. I have to go through the video and figure out what all is happening there in order to give people highlights so they don't have to be subjected to the entire thing. I'm gonna click on the studio logo and just load this back up. 382. Hey, that matches the video where I've... or the Oh Bother's Prime channel that has 2 videos on it. I need to start editing stuff so that I can put stuff out to the main YouTube channel. And this is the VOD channel. So the VOD channel I should also continue. Also, nobody look at that's Willow's a puppy right there. Willow's a puppy. Okay, let's get this out of here. Yeah, so what I have to do is I have to set up a virtual machine to be the MQTT broker. And that's going to need like no resources at all. It needs barely any resources. And that will get my automation working again. But in order to run that, I guess I need to put up a Linux virtual machine, or is there in the App Store an MQTT broker? So TrueNas MQTT broker. Mosquito setup for TrueNas. See, and this is where they say use TrueCharts, but then I looked for TrueCharts. I looked for TrueCharts on the App Store, and I found Grafana, which has the exact logo, but TrueCharts doesn't exist. I think Grafana is what is to be used, but in the web GUI apps installed applications, try clicking on the three dots next to Mosquito and choose Shell. What do you mean next to Mosquito? This is TrueCharts. What are you talking about? Hey, that is Grafana. From the app's shell, you should be able to find mosquito.conf, wherever the app developer normally puts it. Might also consider editing your Mosquito app's configuration to web GUI, storage and persistence, type of storage, host path sample. So it like seems like they're going through something else in order to get to the Mosquito broker. Is this, I install Mosquito, I need to edit Mosquito conf to make it work. How to edit Mosquito conf. Maybe it has nothing to do with this app. This forum isn't really a support channel for TrueCharts. Okay. Need a massive overhaul of DMCA. We really do. Yeah, we really do. How's everybody doing? I haven't streamed for a little bit. I've been sorting this stuff out. This TrueNas migration. Basically, what I had before was a Raspberry Pi that would run Node-RED, my Fermentrack application, and an MQTT broker that was sort of like the linchpin in all of the automation that I have in the shop. And I moved all of that stuff to my file server. People bother, why would you do that? Why not do this more complicated, weird thing? The reason that I did that is that I will not then have those services on, first of all, have them all updated, but have them on a drive that is redundant and won't immediately and stupidly fail like a Raspberry Pi could. So I can get all that stuff set up on one physical piece of hardware to run as multiple somethings and then access them as the multiple somethings. And that will give me all of my automation again, and it'll give me that redundant backup of the data. $120 big crimps at work, and I strained my armpits super bad. Damn, 120 big crimps. You have all of those methods to like make sure you're not putting too much force into your body. You guys need one of those wire stripper things. Those auto crimpers where you insert the wire and something exceedingly dangerous happens on the other side. Bruised palms, yeah. I'm telling you. Watching some of your crimping stuff made me get this tool, and it's kind of amazing. Probably not all that useful, but it's nice and soft and easy, and it uses your whole hand, and maybe it doesn't leave a bruise, I don't know. But it all depends on what you're doing. So the fart box remains in limbo for this whole, I need to prime this camera. The fart box remains in limbo. It unfortunately relies on all of my automations in order to properly work. And so I'm still working to get that done, but it's just one of those things that is left in the limbo. I would have liked to have one nice, succinct stream where I look like I know what I'm doing and I do all the stuff and then everything works at the end, because, you know, that's a nice plot to follow, but it didn't work out that way. Things just don't work out that way ever. All right, and we're still streaky as all frig. It has been hot here. This has been unsustainable. Okay, so, and then I go to the FPS, and I go to highest. Now I can go into the properties again, I can configure video, and what I do sticks. No low light. I'll turn that gain down quite a bit. 43, good, apply, okay. Click OK, and now streak-free shine. That's a little better. And then I need to do the stand light, so I need to bring that up. All my automations are broken, so I have to do everything manually. We're back to basics. Okay, so that one's the IP addresses for all of the, you'll get there one day. Don't call me champ, that's so demeaning. All the Tasmota sockets have trouble coming back onto the router if something happens. So like if a computer restarts, it all goes squirrely, and I don't know how to fix it. I don't know how to fix this. If the router goes down, or it's just if the router goes down, or if there's a power surge, all of the plugs just don't connect again. They get like bogged down by something. I don't know what it is. And I try to go in and hit reset on them, but it doesn't work. It's like a bug with Tasmota. It only works if you power down and power up. And that shouldn't be. And I don't know, maybe I need to like release the pool more often, the DHCP pool? I don't know. But these are fixed IPs from the router. Whoa! I almost died. Bonk. So now that light can come on. And then that looks a little bit more clear. Open up the aperture a little bit. Yeah, the resin printer is kind of insane. I haven't figured out anything else that I've wanted to print, though. Someone popped a pool already? We had a kiddie pool outside for the dogs to play in, but it's too nasty out there. It's just too nasty. There's no escaping the heat. The ability of resin printers to print miniatures is shocking. Just that level of detail, I didn't expect to get such a good model out of it. And if I primed this, it would be much more visible. I know we've already looked at this. I just wanted to. It's been sitting on the desk, so we're gonna get out Dave's module today, and we'll do a little bit of we'll do a little work on that. Hopefully, I can get a little deeper into it. The TB303 schematic is on the file server, so maybe I need to figure that one out. The Windows SMB shares mess up. Let's take a look at that. Let me get my file back. So many finely detailed phallic objects. I mean, really, a screen the size of a cell phone, whatever you can cook up. I do want to get to the car bodies soon, because I think that'll be fun to have little RC car bodies out of it. I know, it's all yak shaving, believe me. Those two streams that I did recently were some of the most yak shavingest streams ever. And then if you follow my Discord, my stream projects section, I had a yak shaving weekend. That's why I didn't stream on Tuesday. I was still shaving the yaks, because in order to get all this to happen, I had to juggle hard drives. And so now there's a 4 terabyte storage drive in the streaming computer. My server now has all of the 6 terabyte drives. So I've gained, I think, another 4 terabytes or so of storage space, extra storage space in the server. While I was there, I might as well do all this other stuff. There's even another yak to shave still. I've got an SSD that I've duplicated the installation to in the server. I need to reboot the server, go into the BIOS, and select that as the boot drive. for now, it's just a redundant storage for the thumb drive, because TrueNas changed to the way they do logs or something like that. So TrueNas writes a lot of stuff now to the drive where your OS is. Before, what it did is it just took that drive and it put it into memory, and then it worked off of memory, right? But now it goes into the drive, puts it into memory, and then starts writing log files to the drive. So now you can't have a thumb drive because thumb drives aren't geared for frequent writes. It'll tear through a thumb drive quickly, is the theory, and it's probably not a bad theory, but it's good to have the redundant OS drive. So I made the SSD into the redundant drive, and now I don't have it booting off of the SSD, it's booting off of the thumb drive. Ah! Can I buy some of that yak fur? No, we're not done shaving it yet. Why are we shaving these yaks? There's just so much. Let me try to get my drives working. That means instead of this, I need to go in through... Yeah, see, this should have TrueNas in it. This should be... Something here should say TrueNas. Trouble. It could still be a permissions thing too. This IP address should be... Oh, wait. Oh, hello. This shouldn't be whitelisted, but maybe it is. Okay, so there's that. Okay, and then project drive. How do I pin this to quick access? No, not pin to start. Do I not have quick access here? I guess I don't. Get GUI, 7-zip, scan with Microsoft. I can just pin it to start. Oh, map network drive? Z drive? I don't know if I want to do that. Well, whatever. There we go. There's my project drive restored to its former glory. Okay, so that should mean that overlays work. Oh, fourth from the top. Wait. Oh yeah, you're right. Okay, yeah, let's. Well, I'll leave it mapped, but I'm also going to put this one on. I'm blind. I am blind as shit. Well, I also have a very bright light in my face. I have a very bright light in my face, okay? Jeez. Okay, so that means that all my overlays... Oh, they might not actually work. My overlays might not still work. They're probably pointed in the... They're probably pointed in the wrong place. Let's see. Well, I guess the next time I start up OBS, I can point it towards them. Yeah, because it's pointing towards FreeNAS project. I mean, I could correct these. I can just do... Well, I don't want to point it towards Z. Oh, no. If I try to open them from here, for some reason, it still thinks that it's... Oh yeah, this one's the wrong one. It's not even the right one down here. Oh, so I pinned the wrong one to quick access. Yeah, it's... I don't know why that's stuck on my network. Just because Windows is crazy. Whatever, I'll fix this one later. How long do you reckon it'll take until the VCO pokes back? I don't know. I don't know, Nightmare Joker. We may do a little bit of building today to build that same filter, but on the breadboard. I bought new breadboards, so I know my connections will be made properly, and I've got plenty of transistors and stuff. We can just put one together on the breadboard, and we can see what it looks like on the scope. Of course, that's another thing to troubleshoot, but I think it'll be a little bit more straightforward because that's another one of the strategies, and not one that I got from the book. That's one that I just know. I didn't get through much of the book. The troubleshooting analog electronics. I'm still reading it, but right now it's a little bit redundant. It's going over stuff that I already know about and stuff that's severely outdated given the landscape of tools that we have in order to troubleshoot stuff. We have a lot of tools at our disposal now that Bob Pease did not have back when he wrote his troubleshooting analog electronics book. There's a lot of things that he does that I wouldn't necessarily get behind. There's a lot of good information in that book, though, especially for the beginner. But like his suggestion on tools and stuff, I don't think I'd go that same route. But it's easy to be a critic on the internet. I got all the cardboard out today. That's why I'm all disheveled. I'm all messed up right now, and the sweat's only just drying. My hair is only just starting to come back into its primordial swaft form. The thing is, like, there was a lot of cardboard. It was like 3 weeks worth of cardboard, and now when I look over to my side, there's nothing here. There's this whole area. This is unreal to me. It's so open. There's so much space. Look at all of this space. Look at all that openness. It's amazing. Many of those projects are mildly janky. Yeah, simply plug your project directly into the mains. That's sort of that old 70s workbook thing. This is troubleshooting analog electronics, and Bob will not lead you astray. He's already talked about, as far as my reading, I've only just started, but he's talked about the one-hand rule with capacitors and stuff, where you let things discharge for a while because it can be very dangerous. And when you work on stuff with big capacitors, one hand behind the back, because if the capacitor is the size of a shotgun shell, it will go off with the energy of a shotgun shell. It is not cool. You can really hurt yourself with those things. I'd be wearing an eye patch right now if I was leaning over that circuit when we blew up the capacitor and I got 70,000 views on the clip. Apparently you need to risk your fucking life in order to get any views. Uwo's Lab is a testament to that. You guys should watch him. He's zany. This is really good, though. This is a really good book. Little bit outdated, but I'm getting through it, and there have been some decent little suggestions on methodology and stuff like that. The whole forward is on philosophy. I guess we need to spool up the scope too. My quick booting scope. This thing is phenomenal. It's like a race car. Here we go. And you can see just how quickly I can get into actually working with the scope, because it boots so fast. It's so quick to boot. It's amazing to see. There's nothing like it today. Just hit the ground. You hit the ground running. You go, you see that signal there? Let me boot up the scope so we can take a look at it. And you're like, I have all this extra time now because the scope, it boots. It boots so quickly. It really does. There's just so much wind in your sails because of because of how quickly this thing boots up. So really, it's like a well-oiled machine. There it is. Jeez. Land connected. All right, good. Well, that's covered in dust, but you guys will be able to see the screen on the screen. This is going to the side. What's going to happen eventually when I get the MQTT broker up and I get all my automations back, we're going to make a flow for the fart box. And the flow is going to start with OBS. And I'll have to choose an OBS project. Remember, all of my file system woes that have taken me 6 days, 18 hours of file transfers were kicked off by the fact that the Node-RED flow that we wanted to communicate with Twitch needed to have the latest version of Node-RED. What a cascade of bullshit. Good Lord. I'm almost there, though. We're almost there. Bloodied and bruised. Harmed by our own systems, what were designed to make our lives easier. I've done nothing but the opposite. That's why I use Sammy. I have a feeling I'd have as many woes with Sammy as I do with this stuff, but this stuff I'm in more control with it. And they're all my stuff. I don't know. Sammy's probably fine. This is just what I use. Once I get the Node stuff running, I mean, it's open to a lot of other stuff. It's open to a lot of other stuff. All that Node-RED stuff means that I can like really automate things on a deep level, and I can activate OBS stuff with it. Isn't Sammy better at doing those like on-screen visuals and stuff? And I think that monitoring program that I have will give me like a dashboard, so I can go to like an IP, well, a port on the server, and then I'll have all those monitoring things. Sammy controls OBS. Okay. Yeah, I would like to like have complicated overlays. So like text would be able to come in that's custom and do this effect without me needing to contact my graphics design guy. This song is very phonetic. Sorry, if you didn't know what was happening there, it's a DJ Shadow song that does like a whole drum thing in the middle of it. People on YouTube are like, what the fuck is his problem? What is he doing? Same controls OBS, WebSocket stuff. I'm still doing the WebSocket stuff. I have to do the MQTT broker, and then all that stuff will start working again, I think. I'm okay. I'm not going to switch to Sammy. Stop it. I'm not doing it. Is YouTube there? YouTube's there. Okay. We should be fine on that front. I may have to go get like liquid at some point because my glucose level's doing one of these. It's going all the way to the moon and then back. Oh, for text overlay? Yeah, multiple layer text overlay is probably something that Streamlabs has now. They didn't have it back in the day, and I was about to switch to a different, whatever it is, a different overlay and donation place, but I didn't. Guess who's... Why are you changing your screen name so much? You get the first time... It's like you're addicted to first time chatting. What's wrong with you? You should be sleeping. I haven't gotten sleep for like a month. I finally got a decent amount of sleep. Look at that. You get that first time chatting thing. That is stolen valor. Stolen valor. I know. I still use Streamlabs because I'm lazy. I should have moved off of it. Oh, you're not my Australian cousin? Because that's who would come in here and say, guess who's awake at 5:30 in the morning? So you're just on that side of the planet then. Sorry. I've misidentified you. My cousin is in Australia, and after a night of drinking, he'll come in here. But the problem is he keeps changing his screen names, and so I've got this like horrible. It's like finding the shapeshifter. It's ridiculous. It's like oh, hey, new person. Wow, you're from Australia. That's really cool. And then it's like, no, it's just me, your cousin. And I'm like, ah. And then I get another first time chatter who says, guess what? It's really early in the morning here. And I go, you're probably from, yeah, New Zealand, Australia, one of those areas, because it's usually 4:30 for him and not 5:30. So I should have known. I should have seen that and gone, New Zealand. But I go, oh, you're my cousin. And they're like, no, I'm not. And I'm like, like, I can't win. I'm living out the Thing reality here in Philadelphia. What's up, Brink GG? How's it going? I was talking to everybody about my file server woes. I've done all the data juggling, moving big pools of data back and forth and getting that all back up. The file server physically is all there and it's all up and ready to go. I have an SSD in there that also has the OS duplicated onto it. It's still booting from the thumb drive, but it is duplicating the OS to that SSD. So if the thumb drive dies, then, so be it. I mean, there goes $60. I didn't spend 60 on that. No, it was like 20. It was a little expensive for a thumb drive, but it's big. It's like a 200 gigabyte. It's a big thumb drive in that thing. I didn't need it. I just wanted to get something that was modern. But the thing that I'm looking at right now and trying to decide what to do is running the MQTT broker, and whether or not, it's basically the discussion that we've been having is, oops, hold on. Let me get into this. It's pretty aggressive with those logouts. Whether to run apps like I am right now I think Grafana has an MQTT broker in it. I don't know if Node-RED does, because these are already based on Dockers, the apps. Or do I run one virtual machine that's going to run Docker and then all of my containers in the Docker? Or do I run multiple virtual machines, which is another thing that I'm considering doing. Maybe I have a virtual machine that's just the MQTT broker and then another one that's just from Ntrack, which is the refrigerator running thing. Or do I somehow spool them in as apps? Do I make an MQTT app, a Mosquito app, and then make a, what is it, from Ntrack app? I don't know. I got to figure out where I'm going from here. Because one of them involves like getting a whole Ubuntu installation. So if I run these, then I've got to install Ubuntu on them and figure that all stuff out. I know how to do Raspberry Pis. I don't really mess with other Linuxes. So could I run these as Raspberry Pis? Apps are better, they're much easier to migrate later on. I'll have to learn how to make something into an app then. Because like there's no Mosquito or MQTT stuff. There is home automation. Tadar. Yeah, Home Assistant is on here, but I don't want to use Home Assistant. I've already got Node-RED. So I have to figure out where I'm gonna get. Either figure out if there's like a place that has the MQTT stuff, or if one of these apps already does MQTT, because that's what my understanding of Grafana is that it does brokering. There should be an existing MQTT container. For what? Because I don't know nothing about nothing. Is there one inside of TrueNas? I've tried looking it up. I don't know nothing about nothing. I am Babby. I can help make Docker images to run as apps. So apps look like Docker containers. There's a Docker image already, but it's not on TrueNAS's default. It's so confusing. The problem is there's this whole history of updating behind it too, where TrueNAS is like, let's go to Linux, and then everything explodes. So we discovered all of this just because my fart box wouldn't work one day, and so down we roll down this snowy covered hill. All right, we got to start soon out of here. That one at least works. Let me turn down the music that most of y'all can't hear, and now nobody will ever hear ever again. Nobody will hear the music that we just heard because it doesn't broadcast to YouTube and it doesn't broadcast to my VODs. So that was the best of DJ Shadow, greatest hits, full album, stolen off of YouTube. Hi, how's it going? I haven't been on for a couple days because it's just been turmoil here. I've had hard drives and file servers just eviscerated throughout the shop. And I've been moving big swaths of data. It's taken over 18 hours of file transfers in order to get to where I am right now. What I had to do was move all of the 4 terabyte drives out of the server and get all 6 terabyte drives in there. So now I have 3 6 terabyte drives in the server. There's still a couple more things that I need to kind of like glue together in order to make sure that all of my bubblegum and paper clips and little bits of string can hold all of the things that I have automated in the shop. All of the, all the strings that make Daddy, would you like some sausage work around here. I have Node-RED, which is connecting a lot of the home automation stuff that would run all of the lights, for instance. And that needs what's called an MQTT broker. And I have no idea how to put that on TrueNAS, and I'll figure it out. I'll figure it out in the next couple days, but I want to do it in a nice, minimalistic way. You got a meeting. All right, go do your meeting. It's okay. We're not going to figure out any of that today. Today, I'm going to struggle to turn on and off like this light, as long as I keep the barn door closed on it, and I don't do this to give you guys all headaches. I'll keep the barn door on this one low. That way, we're blocking most of the light from it. I got to do all this stuff manually. we're going to work on Dave's synthesizer. Now, Dave's synthesizer, as you guys know, it is an M303 from acidlabs.de. What that means is it is an analog synthesizer where it's making the wibbling waves and it's altering them all within itself, right? But it does it with analog electronics. It does not take stuff into the digital realm. When you do digital electronics, you have an analog to digital, because, I mean, sound is analog, right? Sound is a wave. You're going back and forth. That wave, using a coil, can be a voltage, and that voltage goes back and forth across the zero line. And if you take that into DC, you can offset it, and then it's fully DC, so you can have a power supply, you can have transistors on it, and you can alter it with those, and you can take it and sample it. And what happens in a digital synthesizer is you will have waves and stuff in digital form, and ones and zeros encoded in some kind of a way, and that'll go through a digital to analog converter. You have an analog to digital converter on one side, digital to analog on the other. Everything in the middle is digital. It's ones and zeros. For analog synthesizers, everything is waves, whether they're DC offset waves or whether they're on the zero line and they're positive and negative. They represent voltage potentials, and they can swing from one end to the other. All kinds of crazy stuff happens. I'm starting to get an understanding of what's going on in this thing. It is a vague understanding, but it is an understanding nonetheless. Some of the things that we saw last time we worked on Dave's module was okay. Now, keep in mind, we have a full schematic of this synthesizer, right? We know what all the parts are, and we know what all the stuff is. How much of the book did you read through? This much. Not much. I didn't get through a lot. There was some good stuff in there. Some of it is totally outdated, though. Some of the things that were in the... Oh, that doesn't help. I need that to be down like that. And you could actually see the... Oh, well. God damn it. We'll just do it like this. There we go. I got through some of the book. You know, I read some of the book. And there were some really good things for like the beginners in there. Some of it is very outdated because scopes are cheap. You know, having PCBs made is cheap. That kind of stuff, like that outdated kind of stuff that is, you know, first couple chapters, it's really evident and apparent. But I mean, ultimately, it is good advice in the book. I'm not learning too much that's new. Maybe a couple things. Making a list would probably be a good idea of things that we could check. But I digress. We have a schematic of the original TB303, which is the Acid House 303. It's the darling of the Acid House scene. Probably the 505, I think, maybe was used in the production of the Futurama theme song, because they've got that same 1, 2, 3 sample in it. I don't know if that comes from Roland specifically, or if that's only, I don't think it's only on the 505, but that sample, like I remember that from when we had a 505. We had a 505 when I was a kid. But anyway, so the 303, Darling of the Acid House scene, has a lot of components in it that are no longer relevant because technology moves on. In order to do radio signals, we're not doing as many analog things, right? So all of those old analog radio things are no longer necessary. We don't need them. So companies don't produce them, and it's hard. No one could find the 404. Ha ha ha. Was that a module? I think maybe not. Pressure in my ears. So yeah, that synthesizer was produced. It had its heyday. Now it's vintage. People aren't making the chips for it anymore. So Acid Labs, in the sort of boon of the modular synthesizer era, see, people decided that these synthesizers, they do kind of the same stuff with little variations per synthesizer. So why don't you make all of that functionality into modules, and then you can have all the cool parts from all the cool synths, and you can plug them all into each other, right? Sounds pretty cool. Well, in the whole pantheon of modular synthesizer modules, Acid Labs went, let's make a 303. So they actually went through the trouble of going through the 303 schematic and reproducing the pieces of it that you would need for a modular module, getting all the voltage levels right, finding parts that are equivalents in the modern realm. So they actually found a chip that was 5 transistors in a coat that are all super matched. That comes from more modern RF, and they put that into this design, because the old 303 used supermatched transistor pairs, which was this old LM353 or something like that. It was an old CAN transistor, but those are long gone. So they found an equivalent that works, and in order to keep their company secrets, they shaved off the part numbers, which is that's a big faux pas. That's a big no-no. You don't shave off those numbers because that makes your device less repairable. Dave, well, I don't know how Dave feels about it. He probably, at this point, should have probably just sent it back to Acid Labs, where they could have repaired it more quickly, because we're learning a lot about ourselves. All the things we didn't want to learn about ourselves, we're learning them. And we're discovering how this thing works and exactly what goes into it and what it should look like on the outside. It turns out it should look a lot like the manual that we had open with the schematic on it and all the little notes about the wibbling lines. So we are zeroing in on what's wrong with this synthesizer. Something is going on in the transistor ladder filter, which is this phallic little schematic thing that, I mean, it really does look like a rocket ship, that uses the properties, the small millivolt signal properties of a transistor or diode, that's basically using diodes, in order to provide a cutoff filter, a frequency cutoff filter. Well, it's not frequency cutoff filter, is it? It's like a resonance filter or something like that. Anyway, the point is, we should be getting a wave out of it, and we're not. So we need to figure out what's wrong with it, and that means figuring out if individual transistors are still functioning, which goes down to diode testing transistors, which we did. We still didn't find anything. I decided to buy the $60 Troubleshooting Analog Electronics book. It hasn't totally opened my eyes to this world of analog electronics, but it is helping out a little bit. And we'll take, I don't know if we're going to exactly take things that I learned from this book, but we're going to take another look at this thing and figure out whether or not things are doing what they should be doing. I found a whole like analysis of transistor ladder filters and like what the equations look like and what individual, like what the voltage signals are doing per thing, and it's modeling it all down to an equation. I barely understood it, but it fills me with slightly more confidence than I had before. It doesn't really fill me with the confidence that I would need in order to fully troubleshoot this thing, but we're going to jump into it anyway. I need to find that schematic. So let me just go back here, and we need to open up GIMP, because again, Linux people are another breed. They're not like normal human beings, and none of them can seem to name a software project properly so that you can tell your boss that you're using it. What were they thinking? Hey boss, I'm gonna go flog the GIMP a little bit to get that image out for you. Use your brains, Linux people. All right, recent. I need to go back to uploading. I'll do that soonish. I don't know when I'll get to that. In order to figure out what exactly this board was doing. Now, I haven't even shown you guys the hardware. Here's the hardware. It's all over the place. When you have a modular synthesizer module, it's got a front panel. Where's my front panel for this one? I don't know where it is. It has a front panel that goes over the electronics. The electronics plug into a universal voltage source, and then you plug everything in with 1/4 inch, 1/8 inch stereo jacks, 4 millimeter, 3.5. Yeah, 3.5 millimeter. That was the one. Guys, I am at my lowest right now. None of my stuff works. Everything that I've built up is falling apart. Yeah, 3.5 millimeter. You guys got to give your old man some slack here. He's falling apart at the seams. But we'll try to have a good day. We'll try to have a good day today. Tradition of naming goes back to, at least as far as naming operating system, Unix. Yeah, well, look, you can say that the reason that the app is called Pooper Noodle is because that's an old tradition, but I don't think that's going to get you any traction at a board meeting. Yeah, we use the fucking diarrhea tool. I'm sorry, what did you just say to me? I said the fucking diarrhea tool. It's FKN DRH tool. Like, what? That's what it's been called. So, there's no excuse. All right, I gotta make sure that I get this right, because if I plug these things in wrong, we're in trouble. Where's that arrow? Arrow is on the bottom right corner. And then conversely, it should be down here. No, the arrow's over here. Hold on. I was looking at the wrong one. Okay. Hold on. I gotta double check these because I don't want to blow this thing up again. I plugged this thing in wrong. I did it. I was the idiot user. So this one here goes to this one here. No. Hold on. Sorry, I'm super dumb. Okay. Oh, should that one be the other way around? Wait a minute. Okay, I'm unplugging both of these and we're going to plug them back in. One of them unplugged in the... Oh, you got one already? OnlyFans? That's a fun one. Sits here having to look up errors in the ASIMP library. Honestly, it's an affliction. You know, we're doing like hobby projects here, and for the most part, I'm not publishing anything, which is why I use stupid flippant names for everything. But if anything were published past just putting, well, actually, I need to put all my stuff up on GIMP, don't I? Or on GitHub. Git is another one. I thought it was Bother's OnlyFans. Sorry, you should be so lucky. In order to figure out what was going on this board, because again, we don't have the information about the 303, this specific 303. Even though they say they wanted to make a 303, that doesn't mean they're going to make it exactly the same way. If you ask two engineers to flip a light switch, literally like the easiest fucking thing you could possibly do, there's about 5,000 ways that you could design that and do that. And so every single like device is its own thing. Even if you've got the same device over a couple iterations, you can have minor differences. So the schematic that we're given is for the TB303. It's not for the Acid Labs M303. So what we've done in order to improve our understanding of this and be able to actually work on the circuit is taken individual photos of the circuit board using my microscope. I use the microscope because it's always at the same perspective and stuff. I don't think there's less fisheye maybe from the microscope. The images don't line up exactly, but they do line up. And so we take all of the images at the top of the board and we lay that on top of, in a multi-layer image editing software suite, we layer that over the mirrored bottom layer. So the bottom layer is flipped, but we have an overlay of the components of the top of the bottom board. And what we can do then is just draw over all the traces. And so now I've got a record that I can follow where I can see what traces are going where. We went above and beyond the Call of Duty. We didn't need to do this, but we actually removed the chips and saw the traces under the chips and marked those down too. This has been way, 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 way overdone. I probably should not have done all of this for just this one board. But if I can fix it, it is potentially a $600 synthesizer board. So maybe it is worth it for me to spend all this time, in addition to the fact that I'm also learning about analog electronics and how they function. It has 10,000 stars on GitHub. What is with these naming things? Can you add an alignment mark on the PCBs using a Sharpie? You don't need to do that. You use the traces. So between the photos, the traces were evident. Like here's where we needed the photos. It's just this sidebar here. And you can see where it transitions over. I'm just aligning them with using the traces. You've already got marks on them. So, and then when you put the lower layer on top of the top layer, you can use all the vias. All the vias will set you straight. And you don't need an exact one for one. You just make one 50% opacity or whatever. Oops, wait, we're on the wrong layer. If I go to this one and I take the opacity down, you just kind of line it up a little bit as long as it's close. It doesn't have to be exact. It should just be close enough that you could differentiate it from the other circuit elements that are surrounding. Bob's your uncle. So then I drew over all the traces so that we'd have a succinct, top and bottom layer in two colors. When you're connecting the IDC cables, oh yeah, I know the IDC cables are correct. We went through all the trouble. See, the thing is they used riser. They use male-female like risers. And when you do IDC cable, pin 1 remains pin 1. And so flipping it to the other side of the board, it didn't line up properly. So we had to desolder the headers. I didn't want to do it, but I did. There might be like flipped IDCs. Maybe that's something that I should have looked into. Whatever, either way, easy enough to get an IDC cable out. And, soldering one back in is pretty elementary too. So I desoldered them and I flipped them to the other side of the board. And so now our pin 1s will line up with the pin 1s. I just need to make sure that they go in properly, because for some reason, this is flippable. You can plug this in upside down and it'll blow up your synthesizer. Why they did it like that is beyond my recognition. I don't know. The Germans maybe just like symmetry above all else. But it's not helping us, because it confuses us and angers us. So yeah, here's where they line up with the holes. If you plug them in upside down, they're slightly out of alignment. It's like off by just a little bit. So apparently that's your indicator, but it didn't look like that to me, and then blew it up. So we've done further damage to this. So I hope Dave's happy that he left this thing here at summer camp. All right, so this one goes to this one. And then our pin 1 is... Where's our pin 1? I'm looking for a little arrow that's on it. I had a bunch of spicy noodles before today, so I'm going to lose my voice in the middle of the stream. Very, very spicy. Wait, where's the damn arrow? Okay, hold on. I'm gonna sit forward a little bit here so we can actually work on this thing. We'll pull up the schematic in just a minute, because we're gonna probably make the transistor ladder filter. Because poking around with an oscilloscope only tells us so much. It helps to build a functional equivalent of what you're doing. If it comes down to that, we might just be hunting transistors today. Why don't I see the mark? Okay, there it is, right there. I'm like, are my glasses on? What is wrong with me? The lower left is pin 1. So to plug that in and to fully honor pin 1, I need to plug this in like this. So then pin 1 on this one, if we're like that, look for where the cable's pin 1 is. That's right here. So lower left. So down here, I want pin 1. It's like this. Okay, now theoretically, I will not blow this thing up. I'm going to plug this thing in the same orientation as the images, so that we don't get lost. And I've already got the power plug plugged in, which is its own tricky maneuver. The reason that people break these more often than not is because... Hold on a sec. Because there's no keyway on this header. This header is meant to have its own 12-pin connector instead of the 10, and you daisy chain them between Acid Labs products. If you plug it into a regular modular synthesizer, you offset their universal plug that they give you. This thing can plug in any position on an IDE cable. See, the IDE cable usually has all this plastic stuff on the end. Instead, this one has a cut for the pins that would be there, which is very, very dangerous when you're dealing with power pins, because if you plug this thing in wrong, it'll blow up your synthesizer. To the degree where a fellow was in my chat actually shared with us a PDF, and I don't know where to find this PDF, but this PDF had all of the typically blowing up components when you plug the synthesizer in wrong. I mean, like, come on, Acid Labs, just give us like a keyed connector, or have another connector on this thing. Have a 10-pin connector right here. There's room for it right here. You could definitely put one right fucking here. Just a 10-pin connector for the typical modular synthesizer cable. But no, they leave it to you to blow it up. Now, listen, I have friends who have modular synthesizers who blow up modules with keyway connectors and diodes. Like, you don't need to help these people blow up their synthesizers. They will do it for you. All right, so we're going to turn power on this thing. Now, when I get this thing all done, I have to actually tune it too, which is going to be its own pain in the ass. I think something is still messed up in here because the tuning it didn't. Hold on, I'm gonna see. Oh my God. Ugh, huge sneeze. I'm a little worried about tuning this thing because I tried to tune it before and we weren't able to get to the right range. We weren't able to get to the right range of volt per note stuff. I've tuned a module before. I've tuned an analog module before. We have that CEM 3340 chip-based synthesizer, VCO, that works. So I don't know. I don't know. Something is still messed up in here. That triangle wave didn't quite look right. But we looked at the square wave, and according to the repair guide, the square wave looked fine. Let's open up that repair guide before I turn the power on. Where's that repair guide? So, TB303. There it is. Roland TB303 service manual. This is a wonderful document. It contains goddamn everything that we would need in order to work on a TB303, including all the chips that are there, and the, oh geez, my scroll's broken on this. I need to get a new mouse. I don't think cleaning it's going to do anything. I think SteelSeries wear down. They have like their scroll wheel wears. It's like plastic on plastic wear, and then it's unrepairable. So it gives us a block diagram of everything and how it functions, and then it also gives us the absolutely brutal schematic of the main audio path. So we start here in the VCO, the voltage controlled oscillator. Yeah, quality plastic. Hey, it's British design, isn't it? Aren't they a British company? I don't know why I have fucking like Stockholm syndrome for SteelSeries. I keep buying these fucking mice and they keep dying on me. Like, I don't know what my problem is. I'm chasing the dream. We demand mice made of brass. I was going to replace some of the components with brass, actually. I was going to make the button of the mouse brass and then have the collar that goes on the scroll wheel also brass. my infinite mouse. This connection eventually looks like that, and the square wave definitely looks like that. It might be off by like a little bit, but it's very, very close to that. So as far as we know, the oscillator somewhat functions. There might be some problems over here. And we found, by the way, for the most part, the schematic follows this design very closely. There are some deviations, but for the most part, it follows it very closely. This schematic was designed to fit on a page with all the other schematics, so it isn't exactly laid out for our digestion perfectly, and it might actually benefit me to spend a little bit of time redrawing this. I am an artist with schematics. I like them to be laid out in a particular way so that things are clear and easy to follow. This is made so that all the adjustments and inputs and outputs are on this side, and then all of the stuff coming from other parts of the circuit are on this side. That influences how things are laid out. You don't get circuits laid out in a way that you could Google them and then find exactly what's going on. You get circuits that are laid out in a way that puts all the information down on the page. I don't like that. Like there, Q27 and Q24, the two transistors that are there in a line. You have an arrow pointing up, and then you have this circle with a line through it, which is 5 volts, as explained by this box over here. So it's just weird foibles of the way these things work, the way these things are noted down. But so we have a VCO that then goes into a voltage-controlled filter, a VCF, that goes over here to where you've got the waveform selection, and then the waveform selection drops it down this line and into this transistor ladder filter. Now, I have watched the Mortis Klein video on the transistor ladder filter, this phallic rocket ship of transistors. I've watched that video multiple times, and I've gone through a paper that lays out how the transistor filter works, and I still am kind of in the dark. But what I do know is that the two elements here, the 220K and C17, drop this signal down to the millivolts. So what we were seeing on the other side of that was actually correct. We were seeing the right thing on the other side of it. It then dies, and it's really supposed to be going through this transistor ladder and coming out of these two lines right up here where C27 and 25 are, and then going into some kind of a differential amplifier. And I guess the differential amplifier in the case of the TB303 is Q21. In our case, it's actually a differential amplifier chip, which might be broken. That might be the part that's broken, but we'll have to see. That might be the part that's broken, and maybe we can just replace it, because I've got more of them. Maybe we replaced it, and then it blew up again. So we'll check the voltages. This is where that is. And then this is very evidently the transistor ladder filter. You've got TO220, whatever those are. The transistor, like, D-shaped package pads, and then the surface mount specialty transistor pads right here. A fully brass mouse would be really cool. If I had a CNC going, that would be fun to figure out. What I actually really need is a model of the Rival. I need a 3D model of the Rival 600 mouse, and so I can plasticize the rubber parts of it. But I can't find a good 3D mouse anywhere, a 3D model of this thing anywhere. Because I have this mouse, but the rubber has become all stupid and gross. So I want to 3D print all the rubber pieces on it. Because I like the mouse. You can put all these weights in it and make it actually feel like a good mouse. I like my mouse to have inertia to it. Yeah, it's disgusting, right? And so I've been taking gaffer's tape and cutting it out on the locations. But if I could find a 3D model, that resin printer is so good at printing detail, I could have like a perfect little gripply plastic piece. It'd be great. I don't need all the fancy rubber shit all over my mouse. I just need it to remain clean. So yeah, from here, differential pair out there goes down, over, up, and it mixes with whatever this is. So this is probably an external input from the 100K, the 220K. They're just basically biasing inputs. And then you think of, in an analog circuit, capacitors are like, you can think of it like a rubber sheet isolating stuff, or like a balloon filling up with water. Oh, really? Took a scalpel to it last night and cut the soft bits off. What the heck? Wait, what mouse is this? MX Master 2. Ah, one of these. Yeah, I don't like the mouse covering ones. Logitech, of course. Huh, I wonder what you can do. There's a whole world out there of trackballs we discovered. That one's excellent. It's 50% rubber coated. Ugh. Yeah, those rubbers, they go bad with all the finger oils and stuff that they have to deal with. It's excellent. It's just one of those ones that people are really behind. See, I like my Microsoft mouse. I really love that one. I got the MX Master 3S. I love it. I know a lot of people use those, yeah. Don't use alcohol hand gel stuff with about a half hour of using it. Huh. Is that what might have messed it up? My SteelSeries ones? The SteelSeries ones, they just go bad. Their SteelSeries is not really great at making mice. This one I've had for a quarter century, though. I've had it for a long time running this stream. So it's no wonder that the scroll's gone bad on it. But it is a very basic mouse, and it works really nice. This one's a 300, 310. Yeah, it works really, really good for just being a basic bitch mouse. And I can make it orange. Cool. All right, over here. So, last we messed with this, I was cutting off this resistor because the signal going into the rest of the filter was so small. And apparently that's how this functions. Apparently that big 8-volt signal is taken all the way down to millivolts. So that's apparently correct. And it picks up a lot of garbage along the way, which is very strange. Maybe that's what gives it such a rough flavor. No, you basic. Hey man, I was calling my own mouse a basic bitch mouse. I was insulting nobody. One of the weird things about this power supply is that I can't power up without, actually, how do I want to do this? I can't power it up without turning on the output. So I need to unplug it like that. I need to go to plus 25 volts Now I can put in the positive power. Oh yeah, I can turn it on. Put in 12. Now minus 25, and I can take that up to minus 12. That's just how this thing works. Plus 12, minus 12. So we got plus on that one, and then the new one is minus. And we double check, just in case. I want to make sure that I don't blow this thing up again. That I've got the negative on the white wire, which goes to all the way on this side. It goes to the stripe line. So the stripe line is the negative, and that's the first 2 pins are negative. Then the next 6 are grounds, and then the last 2 are positive 12. That's how they do it in modular synthesizers. Why do they do it that way? Oh, I don't know. They wanted it to carry a lot of current, and they wanted it to make sense and be rememberable. Rememberable. Okay, this would be a fixed voltage we could use for tuning it. So I power this up, and then what do? Well, I guess I should listen in on different places. I've got ground established here. Dog's barking at something. Ground established here on a long wire, clipped into the probe, right? So now we can poke anywhere in the circuit, and we've got a 0 referenced, a ground referenced voltage level that we can check. That also references, I think, the other channels of the scope. If we want, I can plug into one of the outputs. Now we know that the signal does not get out the entire synthesizer. That's not the right wire at all. Hold on, let me find the right wire. Where did I put them? I called them up, put them somewhere. Dog is barking. Yell at the dog soon. All right, now I have a signal generator. I've got all kinds of stuff that we can use. My beard is as much a co-host as I am. So we can do a channel 2 on this thing, and we can actually look at the output from the VCO. So we've got, what are our outputs here? This is the control voltage input, VCF in, VCO out is on this side. So if we look at the VCO out, I can plug into here and get an output from the voltage controlled oscillator. Now nothing is tuned, so we're going to get a waveform. And as much as that, we're just counting that as a victory. So yeah, I'm ready to power on. Oh wait, oh yeah, no, it's powered on apparently. Turn it off, turn it back on again, turn on channel 2. And there's our wave. Okay, you guys need to be able to see the scope. Scope, bonk. I haven't even given scope a button yet. Okay, scope. Go into the properties here and refresh it. .2.2222 control. I wonder if its IP address changed. Hold on, let me check here. No, wrong IP. What? Oh. So status, no, wireless, and let's look at clients, wired, and we should have, oh yeah, changed to 223. I don't want to fix its IP address because that'll restart the thing and everything will get all squirrely on me. I'll have to do that later. So right now I'll just redirect this thing to 223. There it is. Changed its IP address on me, little bastard. I have to fix everything's IP. Okay, so this is our voltage signal right now. Coming out of the synthesizer, it's going from +2 to -2 volts. I think that's typical for an audio level signal. If we look at it earlier in its inception, oh, and I take this down to normal levels. Why is that all messed up? Wait a minute, that's 1 volt peak to peak? It shouldn't be coming back as 1 volt. That's technically off. That's not where it should be. Yeah, there it is on the same scale as the other one. So our output is at the same scale as this. Actually, is that okay? Hold on. Let's double check here. We are testing it on its way back at this resistor here, and the only thing that it hits on the way, it comes all the way over here and goes into the switch where the waveform is selected, and then it comes back over to here. So we should be seeing an offset voltage. Let me cook. Yeah, they're now at the same scale, but that comes back. Oh no, that isn't the same scale. That is actually at a different scale. This would be the same scale. So the audio out goes through a little bit more, but this one comes into the next stage looking like that, which seems to me to be a little bit off. So maybe there are still problems with the oscillator. Because what happens is that not very ample signal is going to go through this 200K resistor, and it's going to become this, which is almost goddamn nothing. And if we go down to the millivolts scale, oops, I went the wrong direction. We can see it gets totally obliterated by noise on the other side of the resistor. Not to mention, you put it through a cap, it's going to look even worse. Well, it looks like nothing. It looks like nothing to me. Huh. It's weird. On the other side of the cap, it gets an offset. Oh, yeah, because they apply the 5-volt bias to it on the other side. They're applying the 5-volt bias to it, and then it just obliterates our signal. You can see it's barely there. Just a little tiny bit of a tilt. So, what happened to my beautiful baby boy? So this is out of spec. This is not where the signal should be. If I flip over to triangle wave, a triangle wave is in the negatives. It seems like it's offsetting negatively. So, okay. So we got to find that, we got to go back into the oscillator. We got to go back into the oscillator to see what's happening to this stuff. My trongles aren't cromulent. They're not supposed to be. Look, it's the proof is in the pudding. They're not supposed to be totally, my saw is dull. This is a dull sawtooth. So our dull sawtooth is perfectly fine. Although that's on the output, which is really what I should be seeing on this side of the resistor. I don't know why it's knocked down so much. I guess on the output it might still go through a where's the oh no, this doesn't have an output. Right. It's all internal here. We have CV gate waveform and then tuning, but what is it? The Acid Labs VCO adds an output stage here. So we're on this component right here, and I'm testing on this side of the resistor here. This goes back and over, up and across. We're going to follow it all the way around these other sections. Under here, you can't see it, but it does go under there, and comes back over here, under the board, travels over and down and around. It really does make its way around until it gets here, jumps up for just a little bit. It's not avoiding anything. Why did it do that? Wait, why would it do that? It didn't even need to do this. There's not a trace coming in through here. Why would you do this? What is the purpose? What is the purpose of this? Why did it do this? This maybe is an auto router thing. Why would you jump a signal like that? Why Why is it doing that? It's no purpose of that. There's what? Okay. All right. Okay. All right. I see it. I see it now. Anyway, we come back over here and down and over, and then I messed up the colors in this section, but it comes across the underside of the board and goes into not that header. It goes up and over, apparently. What is that doing? And it goes to here. I've labeled that F in. It's off by a little bit, but nothing else happens on that pin. So on that pin, we don't have, I didn't add to this a top layer. Yeah, maybe there's a trace going in there many, many moons ago. Pointless meeting number 5. Fun. All right, so this is the lower header, and we're 2 pins in from the right on the lower header. So the lower header, let's see if I can get a good shot of this thing. This is hard to do. 2 pins in, sorry, 3 pins in, 1, 2, 3, and that doesn't go anywhere on that side. So 1, 2, 3 goes up and over and into a potentiometer. This one. Wait, does that affect it? No. Okay, let's check FN over here. Doesn't do anything. Will that one be cut off? That doesn't make any sense. No, we're trying to trace it from where it goes into the filter back into the front panel. And so we've got it here. On the other end, it seems to go to this potentiometer. Because it goes to... Actually, no, I'm on the wrong side. Okay, I'm on the wrong side. 1, 2, 3 is actually here. And you guys can't see it, but it goes up and over to this thing here. This is a 2-gang pot. This one here, which is resonance? That doesn't make any sense to me. So if I get it here, and this is a resonance control. Resonance cascade? No. No, dog, I don't think so. Interesting. Okay. All right, well, anyway, let's not get too distracted. We're looking around, and we're seeing where the signal's going, and we're trying to find it. This frequency, the frequency that's going into the filter, is coming from here. It also goes to the switch over here. So I can test on these pins, and I can actually get that signal out. So I know that the switch is in this location. So if I go to this side of this capacitor right here, and that's actually where it's being split out to everything else. So I go to this side of the capacitor, and I probe in. You guys can't see. I'll come over here. There's our buddy, and it's just offset a little differently. Channel 2 is centered on 0, and then channel 1, these are at the same scale. Okay, so these are just slightly offset. One of them is centered around 0. The one that's being output is centered around 0, which probably means that it's coming from here. And there we have the exact same signal on the other side of the capacitor. So that's what we're using these capacitors for. When our signal is offset by a DC voltage, you know, we can offset stuff by a DC voltage and then put it through things like diodes and stuff and get, you know, appropriate results. And then we get rid of the offset by putting another capacitor in there. And the capacitor limits the DC offset. DC runs into the plate while AC wibbles around it. It actually drives around it. That's a capacitor schematic symbol joke. You are allowed to laugh now. Commence laugh. So this is just through a resistor. It looks sad. Looks like it's a little sad when it goes to that resistor. Okay, so that being said, we know where that's coming from. That comes out here through a bunch of stuff back up. Does it go anywhere else? It doesn't appear to. Let's get this on the microscope. You can see the area that I'm talking about. Yeah, I need a button with a laugh track on it. I have the mixer that has all the buttons on it, so I can do the joke where you cut in and cut out the laugh track way too quickly. Just pop. I love that joke. That's one of my favorites. So like, we've got a bunch of stuff that's dropping to the bottom layer. We have a square wave coming in on those vias, going up to the area that we worked on, which looks like total ass right now. The glitches, of course, that's just what's happening on my microscope. My microscope has a lot of little glitches, and that's just how it operates. It's on a long cable that goes through a couple adapters, so Logitech gets a little confused along the way. I should get a new cable for it. I would like to get one that screws in place so I don't keep unplugging it, because if I bounce on it too much, it'll freeze the camera. Camera still looks off a little bit. Oh, that looks a little better. So this area here, oh God, it's disgusting. Hold on. So we can see what's going on a little better. Ah, cotton, no. Do I have scope view here? I do. Oh, that one got the address right. What the heck? Wait, why was scope 222 in the other machine? This one's 223 already. Oh, you know what? Because the scene is repeated over. That's right. Okay, so the settings in the scene persist through OBS. So anyway, these three pins right here. This one is our triangle wave, right there. This one is our square wave. It's not. No, it's not. Hold on. Triangle wave here. Yeah, there we go. See, it's exactly the same. This one's after the switch. So I guess it goes through a capacitor somewhere. No, that's not right. Or OG triangle, offset by DC. Through the switch, still offset by DC. This one should be square. There it is. And our square wave is offset as it should be, but our triangle wave is not. And our triangle wave should be offset by a certain voltage here. It should not be at 0. But this is offset appropriately. It starts at about 5 volts, like it is in the manual. So what's happening after? Okay, so I'm zeroing in on it. I'm zeroing in on it. Ah, the bees! So many bees! Ah! Oh my God! There's like one big bee, one big angry bee. Okay, it's going away now. They're doing yard work. That was the weed whacker coming by. My box of bees. Yeah, so I'd like to order a box of bees. Tell them I sent it. Oh my God, the bees is... I don't know if you guys can hear that. I don't know if it should be audible in the background. We're starting at about 5 volts, so we go up to about 8 volts. That looked perfectly fine. It's just that we're testing it on the other side of the switch. And due to the foibles of how this thing is built, there's also a line that outputs that wave. So the blue trace is on the other side of whatever is being used in order to output that wave. It was ever so slightly audible, because it's really loud for me. It's hard to tell what's going to show up. I know a streamer that does streams in his office, and when he does VR, he insists on not turning on the air conditioner, and it's like he's like going to die of heat stroke. And it's like nobody has ever heard the air conditioner. It's just they hear the air conditioner and they think it's ruining their audio. There's all kinds of stuff going on in the shop that you guys can't hear due to the virtue of the filtering on my mic. Not to mention the fact that there's still a weed whacker going on in the background, but I also have a floor fan that's going woo, 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 woo. I can hear that sometimes on headphones, but typically it should be like gone from the audio. I can't have perfect audio. It's just not something I can have, but yeah, anyway. So the blue trace is what we get on output. We can reconcile that. We can trace it all the way back, but I don't think we need to. At some point, I'll have to take some photos of this board before giving it back to Dave, because I would like to have the full ability to make my own 303. But so as far as we know, signal's coming back over to here where it encounters whatever the hell this knob is. This is the VCO mod knob. Wait a minute. Oh, that's a CV. Hold on a second. CV goes directly into the VCO knob. Huh, weird. Okay, so the output's all the way up here. Here, let's take a look at this real quick. Spend so much time hot gluing parts together on a window AC to make it quieter. Huh. Have you accomplished the goal? So our output signal, and on a typical one, it's this upper left-hand one, but that's not what's outputting here. Upper left-hand. And there might be more stuff going on under the board. That's tough. These connectors are big. Technically, this should be the output, this upper left-hand. So if I probe this right here, in my old apartment, I actually bought this thing that you put around the compressor in order to shut it up. It probably lowers its life expectancy because it's sealing all the heat in, but, you know, it was an apartment, so whatever, I don't live there anymore. I left it behind, its little coat. But it did help. And then I had to put a thing on the top of the cooling closet or whatever it was, just to make it quiet. Why does this go over to here like that? Ah, you guys can't see. Damn it. This goes up and over to here. Oh, you know what? It's flipped 180 degrees. That's what it is. So this one is the output. Yes, indeed. Okay, so that goes to pin probably this one down here. Let's just back this up a little bit. Whoa, no, don't unplug it. So this one goes down, and it goes to either 1 or 2 on the right side. That's not the right one. Yeah, it's the lower one. So that one goes to... Oh, here, I can grab it up here. Oh, but it also goes down to this one. What is that? Envelope out? That's not right. That's not it. This is where the top layer, not having a top layer schematic, is going to hurt me. It's going to hurt me. Okay, so that output that we're looking at right now is up here, and it goes to either one of these. This one? No. This one? No. I get nothing. What the heck? Oh, does it maybe come out the bottom side here? Go to this one? Ha! Plot thickens. Wait, why does it go to both of those outputs? VCO out and VCF control voltage. Unless I'm turned around. Even if I'm turned around, that doesn't make any sense. Why would it go to 2? That doesn't make enough sense. What's that? That one is this one here, which doesn't do anything. This one is a frequency. Yeah, it does change the frequency. So, and there's our switch for choosing our waveform. I think. Yeah, it's over on this side. Switch for choosing waveform. That goes to its own things. It goes all the way. Yeah, those are the pins that we got over on the other side. Man, I'm having trouble with this thing today. Yeah, you carry the one. I'm super lost in this circuit. I don't know why. I'm just trying to trace out where this waveform is coming from in the interstitial stages to make sure that everything's okay there. I mean, where do we see this thing and where are we going with it? I'm looking at this waveform here, that goes into the filter. And it does not look like it should when it goes into the filter, unless Acid Labs has changed things, which I don't suspect they have. Because, I mean, even the order of operations still goes resistor capacitor. It doesn't go capacitor resistor or anything, right? I think they're copying it pretty directly. And the fact that it is only about 2 volts is a problem. That's not what it should be. But then when we look at it all the way back here, where it goes into the switch, like our waveform looks perfectly, our square wave looks perfectly fine. Square wave looks great. Look at that square wave go. It's doing its thing. It's having the time of its life. It looks exactly correct. The triangle wave at this stage looks wrong. It is on the 0 volts to 4 volts, where it's supposed to be at 5.5 volts to 12 volts. But we're not going to worry about that yet. We want to figure out why this thing, like, overall isn't working. I think maybe the waveform is messed up, and the rest of it is not working. So my question is, what else happens to this wave before it gets there? And there's quite a bit, actually. It gets, well, maybe not. It goes through a capacitor, basically. So is the capacitor bad? Maybe. Is there a broken trace? I don't think so. But that triangle becomes this if we put our good waveform through, our square wave. It's like settling down from where it was supposed to be. That's weird. And then it ends up on the 0 line, which it should not. Should not be like that. But it do. All this thing should be going through is a switch at this point. And it should be offset at 8 volts. It's not. So if we go back here and we look at the pins that go directly to the switch, that's just a power pin. There's a triangle wave. Here we are coming back from the switch. And then here we are going to the switch. So it looks perfectly fine there, but when it arrives at the bus station over here, it's all fucked up. Who's at the bus station? What's going on there? Oh, no. Look, it's the AC coupling on the scope is not our concern. We're literally looking at the service manual for a adjacent design. And the adjacent design has the correct, like on that wave right there, that square wave, 5 volt, 8 volt, perfect. So that's our first datum point. That's good, right? That's exactly what it looks like on the signal. Hey, Madam U, how you doing? That's exactly what it looks like on the signal. Good, perfect. That is our anchor for the rest of this. So anchored on the fact that we can see that square wave perfectly, our triangle wave is messed up. And when we get over here, oops, I'm on the wrong, when we get over here to this 220 kilo ohm resistor, it does not appear that we have just gone through a switch. Something there is broken, and it's doing something that it's not supposed to be doing. I wonder how many like audio cues I've set off. I'm just, when things ain't happen the way they're supposed to happen, is always in my brain because of key developmental like cornerstone of what builds me up as a character is the Triple T condense the nonsense office linebacker commercials. And so every time I say that, I remember the incident. And the incident is when an account called Terry Tate jumped into my stream after I recited the whole line, and they jump into my comments and start chatting. I'm like, what the? So there are apparently bots that are listening in on what streamers are saying. So what other phrases have I said in the past that have triggered random accounts, advertisement accounts even? Anyway, so the point is we know that the signal is good. We don't know if the filter works, but we do know that it's not getting a full fidelity signal. It's not getting what it should be getting. It should be getting that signal on the other side of the resistor because it's coming directly from, or theoretically coming directly from the output of the oscillator. So my thought is what differs from the TB303 and the M303 is that the M303 has this modular synthesizer thing, which is an output over here to the rest of the stuff. Now, if I guess AC coupling on the scope, if I unplug this, right, and then I test it here, it's still around the 0 on the number line. That's still around 0 on the number line. So my scope is not affecting it. It should be high Z. So we're back to what we were just doing, which is tracing around the board and figuring out precisely what path these signals take and finding whether or not there is a component causing this or a string of components or what. Somewhere in the no-no zone, the zone between this design and the TB303, something goes wrong. So they added something that broke. And maybe it's an operational amplifier is broken. I mean, I would assume there's a little bit of isolation, but so we can just trace this signal around. And we do know that it comes, like, we know what pins the switch comes from, and we know what pins go to the filter. So what I guess I want to do is I want to find from the filter and work back, or we can find from the oscillator and work forward. Let's try to find the 10K right here. The R36 and Q8 we should be able to find. Let's just see. This involves the front panel, unfortunately. Man, I've got to get pictures of that front panel and get it into the computer so that we can have I can trace this further. I don't want to have to do that though. All right, so let's look at the GIMP. Always comes down to that, doesn't it? This might be Q8 right here. So if that's Q8, that would be, there's a resistor to ground. What does our schematic look like here? We're going to try to identify this structure. So we've got on the transistor, the base goes to two resistors that are across a capacitor. There's a capacitor, there's two resistors. So our square wave signal, actually we're looking at the triangle wave, there's the triangle wave. So this over here, this little goober right here might be our, or maybe it's that one, but okay. I may have to like write this down, I don't know. I wanted to build something, I wanted to actually build the transistor ladder, but it doesn't look like the transistor ladder is, we're not there yet, right? So something along here is doing us dirty. After the selector, so do we think that this isn't affecting it? And then there's this capacitor, a resistor, and then we go back up. So yeah, these are the final stages of the oscillator here. These two. So it is possible that this is the bad component. Let's look at our schematic again. Square wave is coming from, I see. So the triangle wave feeds, and then there's a MOSFET. That's going to be our 6-pin thing, I bet. 550Q26. So all this mess is coming from here, C33. And then all this stuff is separate. 10K, and then there's our triangle. 1051. I don't know if that's going to ground. Well, it might be. This one's going to ground. And there's a 10K going to ground. What is this component? This was a single op amp, wasn't it? Let's figure out what this component is right here. It looks complicated. This little guy right here. That looks like power. Power. 2 power? I don't think so. There's a triangle wave. That one is not quite offset correctly. Ground, and then don't know what that one's doing. There's a triangle output. Okay, capacitor to whatever that voltage level is. Triangle's not quite offset yet. That becomes our output, I guess. Yeah. That goes and comes back. Well, it goes down here and it turns into a square wave. Look at that frequency shifting, jeez. Blech. So that weird triggering signal becomes our weird little square wave. I've got my finger on the other part of the board. It goes off to the switch, comes back and does that. That, and then there it's tamped down quite a bit. Okay. Where's that go? It goes here. Now what is this? What is this component? As far as I can tell, like the weird part is, okay, the part that's messing with me is that something backdriving the RC that causing the signal to attenuate. What's bugging me is that the square wave is being created from the triangle wave. And so the triangle wave isn't functioning, but the square wave is. Why is that? Why does that happen? Because one is creating the other. I guess the triangle is enough to stimulate the transistor and create the square wave. But the whole of the square wave is just over here. There's all this other stuff here to create the frequency. Strange. And I guess the triangle, the sawtooth rather, is being created enough that it's stimulating this stuff and creating a square wave. It's odd to me. It's creating exactly the right square wave. It's just, it's not getting an offset over here. It's like a bad capacitor or something. What would be creating the DC offset of that triangle? Sawtooth. I keep calling it triangle, I'm sorry. See, it's there. It goes up to 10 volts here. That's a chip wave, yeah. Is that Tom? That's not a Tom Thanks. What is that? Giant Trongle. From Giant Thumb, it's great. Big Trongle. Hello, this is me. Big Trongle. I mean, like, there's a triangle wave, but it's just not, it's not big enough. It needs to be big and offset. So it's like over here, we're not getting an offset voltage, like a 5 volt kind of thing. How does that, where does that come from? Hold on, let's take a look. So this over here, we've got our 5 volt offset over here going across a diode. And we don't know if the structure is the same between these two circuits. That's the only thing. We don't quite know if these are the same thing. The design could vary slightly in this area. Although they don't seem to have varied the design very much, because it does look very, very similar. Okay, so that component, that feature, forgot about that. CB, C8, C397. C397, and it's a TO223.5. C397, LM397, mofo. So it is an op amp. comparator. It's an op amp. Where's my data sheet? Oh, this scroll wheel bug is really getting on my nerves. Oh, that's funny. In what is it called? Stream Ninja. It's showing up as a normal sized emote, but on Twitch it's a big one. So that new feature, the new big emote feature. We're still going over stuff that I've already looked up, by the way. So LM397 is a comparator. It's an op amp. Trying to buy another SteelSeries mouse? I know. I know. LM397 device, single voltage comparator with an input common mode that includes ground, 30 volt supply, low supply current, virtually independent of the blah, 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 blah. Typical circuit, R pull-up, R1, R3, R2. I think they followed the typical circuit too. So minus plus S output ground. And that's pretty much what we've got going on here. So output is actually, wait a second. Output's down here? Or no, it's up here. Pin 4, oh, it's in the exact same orientation as it is on the datasheet. Okay, so in minus, in plus, ground? Oh yeah, that is ground. How's that in plus? In minus going to 10K to ground. This one is VS, so that makes sense. Yeah, it's 12 volts. And then this one is output. Output is a tiny little spike. Oh my God, it's the hovercrafts. The hovercrafts are looking for the bees. What the heck? So I got a capacitor going into the in plus. Input is coming from here, basically over here. Why is the output is little spikes? Okay, 30 bits for that. The pricing is set automatically, and I haven't gone into the settings, so I have not gone into the settings. So our trigger signal coming from all the oscillator bits over here, looking perfectly fine and cromulent. Coming out of here, there's a test point for it. Test point here too for just power. Across the capacitor. So we've got a capacitor going to power. We have the collector of a transistor going there. And then we've got power on the other side of the transistor. So here, nothing. Fucking goddamn it. What the heck? Is this the dead transistor? Stay tuned. No, because it apparently works fine. This is one of the components that dies when you plug it in wrong. Okay, so I'm confused. Are you guys confused? I'm pretty confused. There's this comparator right here that is comparing this, which I guess is 10K to ground, with this. And it outputs this. A bunch of little tweaky spikes. But it doesn't go anywhere from there. So I don't know if this is, I don't know if we got the identity of this chip right. If it is in fact an LM397. I mean, VS is definitely there. That's definitely VS. 2 to ground. That does kind of, that tracks, because that goes to ground. That's on this side. Bunch of bullshit is what it is. So, I mean, our power and our ground are established. But it really seems like this would be output here. Because look at that. That's that. That's the output. But then we go over here and we see little tiny spikes. These little tiny spikes. Hold on. Channel 1. Go away. Go away. I pressed the Xbox. There it goes. Did it not choose channel 1? Yeah, see those little spikes? Little spiky boys? Damn it, slipped. I slipped! Little spikes that are timed with the waveform. I guess in the configuration that it's in, that makes sense, because that thing is getting triggered. That amp is getting triggered, and then it's outputting. Why is the trigger so bad? Hold on a second. First off, there. Second off, trigger. Channel 1, rising edge. I should probably say falling edge. That's on auto, so close that. They really needed to make these the X in the corner needs to be much larger in the scope. There it is. Okay, and then right meow. I guess this signal here is the capacitor discharging from those spikes. We should be triggering on those falling edges, but it's just not getting it to get like way up there. It's not helping. All right, if I do channel 2 as the trigger. I just don't get why it's so inconsistent with the triggering. But yeah, you see it spike down at the same time. Oh, and there's a closer look at it. It's a little glitchy right now, but it's ba-boom, right? And then it recovers. And that is apparently what's making these waves. So that sets off, and then it creates a triangle wave around 0. So every time that goes off, I guess what does it do? It bounces back and spikes or something? Triggers a discharge through here. That goes to what? So where does that one go? Where does that go from that 10K? I don't think the amplifier is the problem here. So for the 10K, it goes over to here into this group of transistors. And it gets... Stop jumping around, you stupid scroll wheel. Oh my god, I'm getting a new mouse. Hold on. I'm buying it right now. I'm buying it right now. I'm going to go into this window. I'm going to go to Amazon. And I'm going to look up my previous orders. And search steel. Okay, there's a lot of bullshit that aren't mice. Maybe I should search mouse. Oh, look, the replacement rubber pads for my steel series. Mouse. I'm search mouse. Mouse. And I'm going to find the Rival 310. It is a whopping, currently unavailable, Rival Steel Series. I liked my 310, but it's dead. It's dead now. $30. $92. How much are people spending on mice? Holy shit. Rival 710. $92. I'm not spending that. Shit. My Super Duper 600 was $30. All right, 30 bucks. Ooh, that has like chrome buttons on it. I don't think I want that. I can't believe that my Super Duper gaming mouse is $30. Well, I'm buying it for buying one for this computer now. Wait, that means it's gonna have the same problems. But the scroll wheel issue, you know what? Oh no, you know, we can't fix the scroll wheel issue unless I get a new scroll wheel. Because it machines away the plastic. It's like plastic on plastic, and it machines it away. So there's no chance that it's not just like replace a button. Hold on, before I purchase, let's look up what this involves. Rival 300 scroll fix. And then wait for it to dox me. Come on, you know you want to. Maybe it won't. Open, cleaned out the lint that was spun around the wheel, works well again. Take the sliding feet off and undo it. All right, we'll try that. Get the scope out of here and we'll just try that real quick. We're gonna be in one camera and I won't be able to change anything. So, yep, right now, we're doing it right now. Unplug the moose. That wasn't it. What was that one? Did I freeze a camera? I probably froze a camera by doing that. Shit. Oh, that was my keyboard. Okay, this one is then the mouse. All right, there's the mouse. No more mouse. I can still switch scenes with the Stream Deck anyway. So under the little, they give you little tabs to get under these things. And then you peel up. Whoa, geez, that's on there. All kinds of nonsense. All right. Ugh. Put that up here. Of course, before doing this, you should probably buy new sticky feet because those are a wear and tear item. Yeah, I put them up here. I put them up here to store them. Note the other feet that have made it up there. I'm missing one of those, I think. Let's go there. Got screws. Why is there a screw attached to this? Too big. Oh, I was going to click over and check the YouTube window to make sure that it was updating properly. I did see the Madam U comment earlier, so I think YouTube is functioning. I have a feeling that not that much is going to be wrong with this one, though. I think it's just going to be wear and tear. They're fairly simple creatures. Oh, there is a lot of lint around that. All right, so I've got lint around the scrolly. Quite a bit, actually. Ew. Ew. I have a feeling that it's this component here that's wearing away, though. Because this doesn't feel... It feels like this may have worn down. Yeah, we might have to take that apart. Clear the lint away. Because I don't think it's not the lint's fault. The lint isn't doing anything. It's the nubs that aren't nubbling. You know, like when you get a weak click on the thing and it clicks multiple times, it's because SteelSeries seems to love having the little nub on the mouse wear away on the plastic shaft. And you can actually, it's actually happening to this one. You can see there's like a, well, actually that's meant to be there, but eventually this one will wear away at this one, and they'll machine each other away. They may have changed what switch there was, because it used to be one of these Omron switches there. I still like my SteelSeries mice, though. All right, I'm just going to use a pick on this. But I really don't think this is the problem. Yeah, they don't do it optically. I don't know why. Can't get grip on this stuff. Maybe if I use the slightly sharper scissors, the sharper tweezers, wear out the switches and end up replacing them. Yeah, the Omron ones, they're nice and replaceable. These ones are meant to pull hair, and they do. All right, that's much better, much easier. I don't carry spares of equipment. I just am able to repair everything. All right, so this is a little bump sensor here, little encoder wheel. So I wonder how worn out it is. Now we could take apart this encoder wheel, because I don't think lint is the only problem here. Lint is not the end-all be-all of mouse functionality. I can do this and test it out and see if it still does weird. But I have a feeling it's that component, that just fell apart. The component itself that's wearing away. Ah, coming apart on me. If I were one of those streamers that made like the ultimate kick mouse kicker, I would leave all the screws out so that this thing can explode in my hands. So that seems to be all it's doing right now. Oh yeah, it's still messed up. It seems to be getting down scroll when it's not supposed to be. How do you spell it? Omron? Omron? Omron, I don't know. Haptic feedback mouse? There was the thing that goes in your wrist that detects your finger muscles moving. Yeah, I suspect if I bend the metal piece on the encoder, I think that'll get us there. So I'm going to desolder I'm going to desolder the encoder and then solder it back in. So that requires getting this thing off. So that'll be this screw here with an arrow pointing towards it. You can turn off Dave's synth for the moment. I don't want to spend, this is a $30 job that we're doing right now. You another micro, no, their stock of mice is kind of crap. I don't think they have these. This is an older mouse now. Getting up there in the years. All right, so this comes off. This is just like for lighting, which is fun. It's just got an LED with a diffuser on it, which is kind of neat. And this should snap out. Not quite. Hold on. There's one more screw on the base. I like SteelSeries. I think they're a good company. I think they make nice stuff. For a while, their mice would just die randomly, but Omron? Man, I don't know. I got no idea. I don't know how to say stuff. I don't use my voice professionally or nothing. This should be enough to get it off of there. This is small enough that I think I can do this. Oh no, it's too big. Never mind, we're freehanding it. Onion. Onion? Onion. Onion. Okay, we definitely need flux around it, so I'll just add a little bit of solder. There's some video of a chef, and he was saying onion really weird. It was one of those old YouTube-y kind of shit posts. This is heating up the entire component, because the entire component is held down by these two posts, so I need to get lots of flux in there. So I'm putting fresh solder on it, since this thing is from like 2014. Actually, it's newer than that. When did I buy it? 2020, I actually bought this. Can you believe that something from 2020 is old? Weird. There's still ample solder in there. Jeez. This isn't working. Might have to do chip quick on this. I really don't want to. It's a very simple component, but let's put a big blob of solder down and maybe I can pry it off. Big blob of solder. Using the big blob method. My tried and true method. The only one that definitively works. Hot air would probably work well, but I got a lot of plastic sitting around. So what we're going to try to do is just heat this whole goddamn thing up to temperature, and then I'll pry it off from the other side with the pin tool. I don't think I have any extra mice. I've got my regular mouse, which is now worth $30. I can't believe that. My normal mouse is worth 30 bucks. I should probably buy another one then of my regular gaming mouse. I like that mouse. I don't know why it would be so undervalued. Probably because there's a new model coming out. Weird. It's weird. Flavor of the week electronics. This is not going well. Come on, give me the component. I could put this up on the scope. I don't know if I have all of the stuff to put it up. And we could see the component failing by the signals it's sending out. We just need a ground reference on it. Oh, it's because wired versus wireless? Could be. Man, that did not work. Ow. Hot, hot. Everything's hot. I don't like wireless. I don't have to go find batteries for all my shit. I mean, I guess things recharge pretty nicely nowadays, too. Ah, the whole board is too hot for me to... Ow! All the heat has gone to the ground plane. Jesus. Owie! Okay, I can't keep doing that. Ow. Man, it's hot. Soldering iron can put a lot of energy into stuff when it really wants to. The problem is I don't want to run into the same problem. They with this mouse, it's got these deeper rubber things. I still don't love the, what do you call it? The rubber on the side, but this stuff tends to get greasy a lot less. 20M and a 50M micro switch. About 30M. Can't get a grip on any single part of this thing. It'll just clasp the side of it. Try to figure out what the heck's wrong with my mouse. Okay, you know what? There. Didn't want to have to get to this level, but here we are. You made me do this, mouse. Oh, they got everything labeled too. Batch A2. That's cool. It's like something I would make. A lot of good labels on it. Oh my god, they're back with leaf blowers. Something's always got to be leaf blown. All right, so now I can actually, this is putting a good amount of pressure on it. So now I can come in here with the big solder blobs and try to walk this thing out with dignity. They go in so easy, but they don't come out. At this point, I probably should just use hot air. Ah! Ah! Mine lasts a month on 40 minutes of charging. Yeah. Ain't doing a wired mouse. Wireless, sorry. Hackers will get all my mouse movements. Come on. This thing will not budge. Might have been a little movement there. Gimme this component. Oh, this piece of shit. All right, fine. You don't get to win this one, mouse. I'm the wiener. Wired mouse is like a ball and chain around your leg. What are you talking about? Crazy talk. Let's get some flux down on this. Where'd my flux syringe go? Why is it gone? Wait a minute. Why is it go? Oh, it fell down. Okay, here it is. You crazy person. It's ridiculous. No, that doesn't count as a win for the mouse. Yeah, this one has a big ground plane. That's why it was burning me earlier when I was trying to hold on to the front. I pour all of my hatred, all of my malice into this hot air. God, I really just got to hold it on. Now, I got to be careful about the amount of force that I put on this because I don't want to pull pads up on the other side. When there's a pad on the other side and you put a lot of force into pulling something like this, if this stuff isn't molten, it'll pull up the pad on the other side. Especially given the amount of heat dissipation we've seen on this thing. Yeah, we're trying to fix my mouse right now. I like SteelSeries, but they break. Almost there. Thought this is all gonna melt. The big iron tip might actually reach all these at once. Yeah, the big boys aren't coming with. All right, so that didn't work. All right, put that back. My hand hurts. Ah, there we go. Okay, so I'm gonna do the big iron tip, and that'll be able to reach all the pins at once, because the ground plane is just sucking all the heat out of this thing. I think we can still fix this. Okay. Now, did I pull anything that shouldn't have been pulled? No, it looks like all the pads are still there. Clean up all the pads and just make sure everybody's okay. And it turned out using the giant iron tip was the way to go. So, a little desolder braid. Can't do this on the microscope because I don't know the mouse. Well, I guess I still can. It's actually just looking at... let's see. Boop. I've got the only scene here. So that's where we are. The hot air was useless. With the big iron on his tip. And that's always stuck in my head after I use that iron. This iron. This is probably too expensive. Hold on. Desolder braid is not cheap. Let's watch our expenses here. Okay. You know, the Fat Man version of the soldering iron. Actually, I have that. The Fat Man soldering iron is the butane soldering iron. This is Chemwick. Sorry, Chemtronic Solderwick. It works good. It always works good. That's why I buy it. Also, the board's got a lot of heat in it already, so this is doing a kind of a wonderful job. Okay, so we got a couple Q-tips over here. Just clean this off real quick. Even though, you know, if we break this component permanently, that's going to be a problem. But this is an on-the-fly mouse repair while streaming. This is the kind of shit that I do around here, and you guys can appreciate. There's a lot of flux on this thing. Hold on. A lot of flux ran sort of all over the board. Oops, we gotta work on that. Went right into the thing. Darn it. All right, a little bit of wick goes a long way. That bee might mess with us. I'm going to try to put the component back. That'll be a little better. Okay, so yeah, look at that. They have a different component for the mouse click wheel. And it's got the same style, but it's a little thinner. Huh. But that's just for mouse click. This is the encoder. That's what's giving us the scroll wheel action. So I need to look at the encoder itself, see that it's in good shape. So move all this stuff out of the way. And we've got the encoder. And it is an Alps, so I might actually have a replacement for this. I don't think I have a replacement for it directly, but I did have a lot of Alps stuff in a bin once. Giant blobs of solder. Let me get those off. I shouldn't hold it like this because this is going to end up burning me. Big bloob solder. Bloobs, bloobs, bloobs. Everybody loves bloobs. Out there. Let's see if we can coax this one off. That's as much as I'm going to get off of it. Okay. Yeah, if solder wick is giving you issue, flux is just the way to fix it. It's just what you do. Come on. Suck it up. I guess that did it. I don't know. Didn't really look like it did. Owie, the component is getting hot. I should probably put it in the vise. And then we'll pry away the outer exterior once we get all of this additional solder off of the component. I want the component to be clean. Nice clean component. Clean coal. I saw a meme recently. Did you guys know that? You guys ever hear of these things? They're called memes. They're like inside jokes for the internet. Anyway, I saw one recently that was a fantasy setting has flying creatures, but everybody gets around on horses. And the response to that was fantasy world has nuclear power, but powers everything with coal. It was a good one. I chuckled. I had a sensible little chuckle at it. I said, ha ha, yes, ha ha ha. That's how it be. Okay, anyway, this thing is clean now, so let's take a look at the component itself. How's this thing functioning? So this is an Alps encoder, and it's an AB style encoder. So it has a common, and then it has two outputs. And so it flips between those outputs in order to give you an impression, or in order to give the microcontroller two pulses that alternate between one another. Now, this is a plastic component with a metal shell around it. Metal shell gives it strength, makes it last a little longer. So inside, it's going to look a lot like a switch. And there's going to be spring elements. So that's what this is right here. That's a spring element on this piece, and that allows it to flip between these little gates so that your mouse has this sort of thud, thud, thud kind of feel to it as it's going from gate to gate. So what we're going to do is going to get into this thing, and we are going to pry the springs just a little bit outwards, assuming that the tracks that conduct don't have significant amounts of wear on them. So we just get these pins, we just need to get them out of the way a little bit. We're not going to get more than one bend out of any of these, so we've got to be a little bit careful about this. I'm not going to overdo it with bending these things, because this metal is the worst. It has a bend to it. Oh, and I crushed that by handling it too much. So you got to be real careful. I'm not going to fully open this thing. I'm just going to open it a little bit, and it should pop out, basically. What I'd really like to do is back out the entire side, which I guess I could do once I get these pried up. But I don't want to pry them all the way. I want to get them a little bit because we've only got so much movement in this metal. My hands are shaking a little bit after all that desoldering. It's like that. And I'm going to bend the outer shell out a little bit. Maybe that won't work. Ow. It dug into my hand. Yeah, I'm going to come in here and just pry it outwards a little. This is so I'm not going a full 90 degrees with anything. I will crush this thing back into shape later. Ah, damn it. Those are not gonna, that's not gonna do well. That's not gonna be good. I might not be able to fix this. We'll see. There we go. Okay. So now we can see what's inside. It might be okay. It might be okay. I might get away with it. Push comes to shove, I could solder something onto the back to hold it together. But so our AB encoder is just this little wheel that's full of crap. So number one is probably going to be cleaning this out. Is that full of crap or is that worn down? I think it might be full of grease actually, which is good. This is Alps. This is a good company. They make good stuff. Show me your inner workings. So this spring clip would be one of the things that I want to tension up a little bit. Although it looks like it's in pretty good shape, but I guess what I'll do is I'll just take this like this and just bend it a little bit. And that's gonna give it just a little bit more oomph into those tracks so that it doesn't go backwards, basically. We'll just put that aside with the top piece. Let's see if we can get in here a little bit more. Here, I would like to actually go to the right scene. Oh, here we go. I can use up and down scroll to get here. I don't know what right and left is doing. The scope is getting in the way. Well, oh well, can't do anything about it. I don't have a button for it on the overlays. So this looks like it's completely sealed, isn't it? If we're not getting in here, then I don't think we're refurbishing this. Yeah, it looks like it's plastic welded together. See, there's like plastic rivets on this. Those two big plastic rivets. I mean, I can clean out this part, but we can't get into the actual element to see what's going on. Let's see if I can just push it from the other side here. Push it through. Ooh. Bump, 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 bump. Nope. Push it. All right, let's scrape this out with a pen tool and just see if it gets better. If it's crud in here. Because, like, my theory is that these little gears are worn, and so it's not bumping over into that little bump stop as much as it should. Oh yeah, that's crud. So how do we get that crud out of there? I mean, that could just be grease that they put in there originally, so it might not actually be hurting this thing's ability to click over. Yeah, a little with mustard. Whatever it takes. Get out the wire brush. I mean, I can get a 5-volt source going and we can just see this thing, how it switches on the O-scope. Jeez. Yeah, I don't think cleaning them out's doing anything. I think they're just worn out. It'll help a little bit with just tensioning that spring more, but it might still be finicky. It might still give me backwards readings because it's not definitively clicking into the gear sections. Let's I mean, I guess we'll just do slight retensioning and that's it. That's all I can do. So let's see, this thing here goes back up. Come on. What could have prevented this? Well, having a metal piece. The only way this could work infinitely is if there was a metal piece. Print a new gear on the resin printer. I guess I could. The resin printer would be able to do that. The resin printer is so much of a pain in the ass, though. I guess that's what most resin printers think. Get you guys in the mindset of a resin printer. That looks like it's a pain in the ass. I don't want to do that. That's all there is to it. I don't know how resilient to the twistings the resin would be. All right, you guys need to go back to this camera because there's nothing that exciting going on. So essentially what I've done is I've retensioned this so I can put all this stuff back together using pliers to squish the sides, and then I'll squish down the tabs. Just like they did in manufacturing. Manufacturing, if you're Jeff Bridges and Iron Man 1. Okay. I used to do this with stuff all the time. Take apart your potentiometers and stuff like that. It's good to know that you can get into your electronic components on this level because it unlocks a whole lot of repairability. Maybe it's not a $30 mouse. Maybe it's a joystick that you really like. Getting into it, being able to get in there, fix stuff on this level. But just a basic inspection like that can help tell you what's wrong. In this case, I think that the little tabs for the encoder are so worn down that they're not locking into place, and so it kind of dribbles. It sort of goes back and forth when it hits that scroll location. So a temporary fix, this may not last too long or it'll last 1,000 years, but a fix for it is just retensioning the spring that falls into those little areas. I'm still streaming, right? What does he's dead mean? So that goes back in here. Oh, the encoder. If you're not dead, it's fine. It'll gonna be okay. Right, so just solder that one back in. Stream's fine. Okay, good. When I hear stuff like that, I'm like, oh no! I don't have a mouse! Why don't I have a mouse? I can't do anything about it. All right, so what I want to do is I'm going to solder one of these feet, and then I'm going to push down on the encoder from the top. The top is metal. It's going to be hot, so I might burn myself doing this. I just want to make sure that this thing is seated. Okay, I think it is. I think that's good. I just can't believe that the Rival 600 is $34. I bought mine in 2020. It was probably like 100. I think it was less than that, but still, principle of the thing. All right, so I wonder how long this is going to last, or if it fixed it at all. Let me make sure all these are soldered, though. Seems like they're partial. All right. The worst thing that I could do is plug the mouse scroll wheel back into this thing and have it melt. I don't know where that mouse is going to melt or not, but... Oh, look, and this way I can get all the lint. Ew! There's a certain amount of lube on the thing, too. All right, so is this a D-shaped shaft or what? Can't even see it. That one's solid. The thin one goes in there, and the thin one has, I think, a cut in it. Yeah, it's not going back in. Did I distort the thing too much? Or just not align it properly? All right, let's see here. Try to hold one, and then maybe we'll do this with a microscope. Boop. A stupid shadow. Oh, I see. There's a little shaving in there. What's going on here? The heck? Well, I can see what direction it's facing. This is chaotic. All right, so there's that. And then this one goes... Oh, it's hexagonal. Wait a minute. How does that work? Is that whole thing hex? So really, it just needs to line up with a hex. There we go. Ooh, that feels crunchier. That has a lot more crunch to it. Maybe that'll solve it, maybe not. It might just prolong it. Yeah, they feel rounded. They feel very much rounded down. This may be a new mouse scenario. Or a new Alps encoder, if I can find another one of those things. I don't know what the bottle is, but maybe. It's going to be like $12 for me to get an Alps encoder, or $30 for me to get an entirely new mouse. You got to kind of pick your battles sometimes. I like how the mouse wire goes all the way in and around the PCB. It comes in from the front and goes all the way to the back of the mouse. Strange. Where's my mouse? There it is. Where did my mouse go? Where does this route? It goes under the PCB. Yeah, there it is. Ah, get the solder out of here. Hold on a second. Change the button switches while you're in here. They don't need changing. They're perfect. They're totally fine. Also, I don't think I have Omrons sitting around. I may have one or two. Yeah, that's a silly thing to have on hand. I don't have stuff like that. Why are we ripping? What's going on? No, this will work just fine for a while. I'll see if I can find that Omron encoder. Or sorry, Alps encoder. This cable is not cooperating. It needs to be sandwiched down by the top of the PCB. The top PCB, rather. It's like pushing it out of the way. Oh, no, there. That's where it should be. There we go. Okay, everybody back in place. That all clicked in suddenly. Wait, what are you doing over here? Oh, there we go. There we go. A couple more clicks. That's what it's for. Okay. That's there, that's there, that's there. That feels like it's off. No, once it screws it, it should be fine. All right, so first one would be this one right here. And screwdriver and internal versus external screws. 2 sizes. This one would be one of the internals. That right there. That's my illumination for the scroll wheel. And the internal screws. 1 or 2. And 3. And the top go down. These guys. So many yaks had to be shaved that I had to take apart my mouse during stream. Live mouse repair, yeah. The scroll wheel was getting a little squirrely. And I think what it is the spring tab that hits up against the gears on the encoder in order to give you that lumpy scroll was worn down. And so what would happen when I'm scrolling is it would register an opposite direction scroll, which is incredibly annoying when it happens to you. So we just took apart an Alps encoder and gave it a little bit more punch to the spring. And that's not really going to fix it, but it'll get me a little bit longer, just a little bit more mouse usage. Otherwise, we've been poking at Dave's synthesizer, so it's just as frustrating as this. Actually, way more frustrating than this, because I'm good at this kind of stuff. I can fix a mouse live on stream. The very mouse that I use to control my setup. Where's the mouse wire? Oh, there it is. It's right here. Okay. So I'm going to plug this back into USB. We'll see if I fixed my mouse. Bonk. So we know it works, but the question is this going to be more consistent? It is. It is immediately and demonstrably not scrolling backwards when I scroll in a direction. So it was wear and tear on the little nubs of that flat gear. Look at that. Beautiful. So that means just delaying a $30 investment? Yes. I can close that Amazon tab and we'll see what mice are popular when this thing breaks. Okay, we're back in business, which is bad because I don't know what the hell's going on. Like, they call this the typical circuit for this piece, this LM397, which is what we were testing. Ah, Brink Gigantified, yay. I'm still on the fence about that, but I don't think it's that bad of a feature. I know a lot of streamers are like, yeah, it's new and I hate it, but it's like, I don't know, it's kind of fun. Yeah, it's fun to make a big emote. Some people just hate. They just hate. I can just stop there. Some people just hate. We're not about hate here. It's all love, baby. All right, so what the fuck is going on with this stupid piece of shit circuit? I hate it. Fucking hate this circuit, and I want to break it. I want to just break it. I want to take my pin tool, and I want to pry the components off of it. One by one, until it no longer functions. Hey, I don't even need to do that. It already doesn't function. We've been poking around Dave's synthesizer, and we're trying to figure out where the hell this thing has gone wrong. My mouse no longer pisses me off, so that's now one less thing out of the 10 billion million zillion things that piss me off in this shop. One less. I need to do a lot of cleanup. That's where the file server is right now. It's like, do the cleanup of the file server, and then I clean up stuff in the real world. We're going to do a 3D printing table on the other side of the realm, and I need to figure out how I'm putting a camera there. I've got the lighting equipment for it. I can definitely light it. I just need to somehow get a... well, I'll probably have to build something in order to light it properly. I'll have to figure that one out. All right, let's turn Dave's thing back on. Turn the hot air off. Turn Dave's thing back on. And let's see if we can chase down something. We're looking at okay, so PEBCAC, right? We're looking to see, we're ruling, okay. Let's try that one again. We're trying to rule out sections of this synthesizer to figure out where it's all gone wrong. There's no output from the synthesizer. So if we look at the outputs from the wibbling wavy parts of the synth, which go to a switch that selects your waveform for the rest of the synthesizer, right? So in terms of like a block diagram, we have the parts that's the VCO, the voltage controlled oscillator portion. That's the first thing, that's the top of this control panel. And so our VCO out is right here. And if we VCO out, we get a good signal. It's a nice, 5 to -5 volt square wave, and it's got that little pompadour that is common of the M303. The M303 is square wave. The sawtooth has a cut tooth, right? We have a dull saw blade on our sawtooth, and then we've got a pompadour on our square wave. That's the M303. That's the waveform that the M303 specifically creates with its circuit topology in order to make that hard acid house sound. It's very popular, very rough sound. Not rough, but it's it's its signature sound. So anyway, our signature sound is coming out of that VCO, but it's not making it all the way to the end of the synthesizer. When we look at that signal and it comes into the diode ladder filter or the transistor penis filter, it looks much different than what it should be. Mowdy, hey, thank you for the Prime. By the way, you guys, if you guys have got a Prime sub, it's on you to use it. Nobody's going to remind you, not even Jeff Bezos himself. Jeff Bezos is sitting there on a pile of your $5 bills, and they remove one from under him every time you guys use a Prime. Because you're paying for Amazon Prime anyway. I do for the shipping. Because holy shit, would we have spent a lot of money in shipping without Prime. I order parts all the goddamn time. So that's one of the things that Amazon actually helps me with, is being able to order a lot of these little electronics orders and not have to worry about each one individually shipping or having to be responsible in life and not be a giant bearded man baby and make a list before doing it. So I don't often gush about Prime. A bridge over troubled water, subbed with Prime for 46 months. Hey, thank you. Oh wait, that's a non-Prime? Oh my God, you've ruined everything. My whole spiel is nothing now. It's all come crashing down around me. Anyway, a Bridgewater, thank you for the regular sub for 46 months. I really appreciate it. Mowdy did a Prime, and anyway, I have Prime anyway, so I use my Prime on the streamer that I like. Yeah, so you got make sure you do the same. I don't want Bezos to get any added value off of people not using their Primes. This is about revenge. It's not about subbing. Look at that signal. It got even worse. Like, none of these affect the magnitude of the signal. That's frequency. Yeah, none of them affect the magnitude of the signal. What about those who don't have Prime? Well, let's logic this one out. If you don't have a Prime, if you don't have Amazon Prime, what do you do with your free Amazon Prime sub? I'm not always going to be here for you to help you figure these things out. Okay, so we got our signal over here, but it's not the right thing, right? On both of these channels, okay, if I set them correctly, channel 1 set to the same voltage range, right? So this is what we get. We get exactly the same signal that's coming out of the synthesizer, which is not what we should get. Mowdy gifted a sub to X Winter Gaming. Challenge accepted. Thank you, Mowdy, for the extra sub. I'm happy to be like in that meme where it's Tony Stark and Batman fighting with money and Spider-Man's in the middle. I'm happy to be your Spider-Man, chat. Okay, so we get the exact same signal, which is really, really frustrating because we're trying to trace down why it looks like this. Here's the thing, is that this isn't the TB303. This is not the TB303. This is the M303. This is made to be like the TB303. So the notes that we have on the functionality are not necessarily applicable. But in many of the cases, we see the same signal that is being detailed in the technical document. So 5.5 to 12, or in our case, 5 volt to 8 volt is the one that we do see. If we trace back the signal all the way back to where it comes from, here, it's now incomprehensible, but if I take this up a little bit, you can see, well, okay, so you can see at about 5 volts, the signal starts and it goes up to question mark, which is around 8 volts, which is around 8 volts. You know, I can actually take our 0 point down here a little bit and you guys can see. Oh, I hate how fine-tuned that is. What the? Stop moving my signal around. So there you can see it gets a little bit over 8 volts. It doesn't quite, and that's down to, I think, component differences or where we're measuring the signal itself. So, like, all things considered, oh, you guys triggered a hype train. Nice. All things considered, like, that square wave should be perfectly fine. And that should be going into a same value resistor in order to create a millivolt level signal. So that goes to the switch over here, and then it comes back and goes down. Now, we've already been over all this. This is the part that really kills me, is that we've already been, hey, what's up, wonky robot? We've already been over all this, right? We've already established that this is what's going on. We just still haven't found what's wrong with the actual component. So right there at that 220K resistor, that is here. That is right here at this 120K resistor. Tequin Dragon subbed with a tier 1. Hey, Tequin Dragon. Am I saying Tequin? I don't know if I'm saying that right. Tijuan? The Toyota Tijuan. Or no, that's VW. Tijuan. Right frickin' here. And we should be getting a much larger signal. If you don't have a Prime account, you don't get one. You get it with the Prime account. Wait a minute. You're probably just joking, and I'm taking it too seriously. Okay, so our signal comes in here, and you can tell we've been probing this thing a lot because there's a lot of flux garbage sitting around that component. But like, it's not good. It shouldn't look like this. It should be up there. It should be all the way up. So something is happening between these two stops. And so what I'm trying to do is establish what it does between looking like this and looking like this. So we can trace this trace, and we can trace it back all the way around, all the way until, using our two pictures, we can trace the trace, we can follow it all the way back. So we're sniffing, we're snuffling our way back, hounding this trace right here over our hand-drawn trace. It's artisanal hand-drawn. Over here, up, down, and over. Now listen, if you've ever designed a big circuit board with a lot of signals going on it, you know the trouble of having to get one signal from one part of the board to the other. There's 10,000 ways you could do it, and you just have to hunker down and just start weaving. You have to start basket weaving your trace and doing weird shit like this, where for some reason it does a jog over here, jog over there, jog over here, goes to a via, comes up to the top of the board, goes straight down, then back to a via, and then across. Because maybe in some revision, there was a trace that went through here, going left to right. But there's not now, so it's just this nonsensical pair of traces that you wasted. And we come over here, and then we go At a 90-degree angle, we come down this way. Now, this is a mistake right here. This is me forgetting to switch colors. So that should come down as blue and then go over this way to where it appears to disappear. Now, if I bring in the bottom of the board, we can see that it actually just comes across and goes to that third pin in of the header. Oops, where am I going? Oop, there we go. So I'm calling that frequency in because that's frequency or filter in. That's the input to the filter. So now I want to figure out where this goes on the top board. And I'm coming in 3 pins in. So somewhere between the selector switch and frequency in, we have our output. We have our output and we have something. Something is messing up our signal between these two. We got to figure out what it is. What is? That's where we are with this. Need to put the scope on a button. Man, I was like, one of the things that I would love to do is the stuff Uo is doing right now. He's putting like huge vibrators and controllers and stuff. It's like, oh, who's that one guy that was doing that? Making controllers out of whatever. We got to get back to that joystick project too. That's a totally doable project now. do.s is apparently on this level of the, this is do.s right there. Okay, so our signal is coming in on this pin of that header. Apparently not. 1, 2, 3, right here. That should be our signal. Oh, unless we're upside down. No, we're not upside down. This is VCO out. This is volt per octave in. And this is our header. And 1, 2, 3, we trace this out. We know the signal. Is this what's messing up? Huh. Okay, cool. Why doesn't everything just be wrong? There's our signal. Oh yeah, you guys can't see. Scope right here, turn that on. Oh my goodness! We got level 1 hype train emote, which is another kind of incomprehensible emote. It's a bear with a baseball bat. That's what I can see from here. Twitch is not good at these free emotes. These free emotes are always a little bit, something off. That's our wave selector. So we are right side up. Do I need to double check my wires here? Is it that I've plugged it in wrong? Could be, could be. So pin 1 is this. This is pin 1 right here. Yeah, this is plugged in wrong. What? Hold on. Double check. So, plug it in like this. Oh, these are flipped. Let's go ahead and turn this thing off and think about this a little bit more. Let's make sure that we're plugging this thing in the right way. Let's unplug these two. Oh no, you know what? I think the board was upside down. Yeah, it was. I had those upside down. I'll just double check for my own sanity. These are misaligned. Yeah, those are misaligned. Okay, yeah. So it was plugged in correctly. I just got turned around. Yeah, it's supposed to go like this, but we had to desolder these headers and put them on the other side so that our IDC cables would plug in correctly. No, it was plugged in the right way. There wouldn't be anything going on if it was the wrong way. Yeah, so this one has to go here. And I'm going to check again. This lives in my head because I've blown up the board before by plugging it in wrong. So it lives rent-free in my noggin, and I'm constantly scared of it. So if we're plugging this in, it goes like this. Those are hovering over the right spot. Pin 1, and which one is... Pin 1's there, pin 1's there. So this plugs in like this. And then we check over here. Pin 1's here. Pin 1 to pin 1. Pin 1. Just like that. Pin 1. And then sparks fly. Everybody dies. Why did I see a spark? Wait a minute. Did I see a spark? No, that was just optics. That was just optics. That was just strange optics. Draw this way up on both boards. This is where your markings would have come in handy if I put key markings on it. Hold on, double checking, because this plugs in straight like that. That is wrong. No, wait. Arrows there? Yeah, arrows there. Okay, this is correct. This is correctly plugged in. Yeah, it lives rent-free in my head. So yeah, this is flipped. So we're actually here. This is not... Wait, this is where we are. No, no, no. This is the power one, and we're down here. But that means that this goes like this. So we're down here. But that still, pin 3 there doesn't give us that output signal. Here's the weird thing too, is that it's settling down from this high voltage. So I'm suspecting that there is definitely a bad component. We just need to get out of our own way and test these things. So like, all right, this is the frequency selector. This plugs in this way. So we're over here. I thought we were over here. Are we actually... Sit down like this. That all section's there. This one is the one... Yeah, there's that signal. These shorting out components? Well, they would have to be in contact, and there's coding on them. It doesn't appear to be. I've never had troubles with it. I'll have to be careful of that. Do I have this, like, why am I so turned around? I'm starting to get mad. Okay, so this is upside down. This is the frequency selector. Yes, good, confirmed. So then we have tune. This would be slide in. And this is the header that we're looking at with these specific components. So this is our signal path. So then 1, 2, 3, right there, I get that wave. That means 1, 2, 3 right here. There it is. Okay, there was oxidation on the pad. The pin has oxidation on it. Yeah, I gotta be careful about that, because if these grippies are metal, maybe I'll put like a piece of rubber on them or something. So that one's coming in there. Okay, cool. 1, 2, 3. So 1, 2, 3. Dun, 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 dun. Dun, 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 dun. That appears to be one of these that goes to this tune control. Oh no, or it breaks off and goes all the way over here to this. You kidding me? Or maybe it comes from over here? I feel like I'm taking crazy pills. I feel like I'm taking crazy pills. This is 1, 2, 3. That should be right here. So that could come up to either of these 3, but it doesn't appear to. Or, well, no, it doesn't come off of this side, because you can see, oh no, it does. There's the trace. And that looks like it avoids the switch. I know it's hard for you guys to see these traces. I can't really show them to you in a good way. I could maybe put this down on the desk and we could try to discover it together, but I need to flip the board over constantly when I'm hunting these out. So this is coming and it's going around this potentiometer and it goes to this via right here. And then I need to flip the board. And then that via takes it over to here. What the fuck? What is this one? This is... VCF in, voltage controlled frequency input. Oh, voltage controlled filter input. That's right. VCF in. So when you plug in a VCF, it cuts off the internal oscillator and your waveform goes in instead. That's what they're doing here with the switch. Okay, that makes sense. That makes sense. So from VCF in, and we're still this tiny little weak signal. So VCF in on this pin is what cuts off right here. And so from that pin, we go all the way up. Oh my God, it shoots all the way up and around. And it goes to this via here, where it goes to pin 1. Okay, so it goes to the corner pin. Now, there's the filter there, so we're turned around. So this would be the bottom row, this corner, this pin right here. Okay, progress. So our signal from the filter side goes all the way back to this pin through a connector. So I need to write that down. So what layer are these things on? Oh yeah, here's voltages. I should probably have those on too. So this goes, all right, let's see here. So it's from here. I guess this would go, oh, Control Z. Go that layer, and then I guess we do, let's see. What does that look like again? The connector symbol would be like a ring, and then you have like a switch. You have another thing there. I don't know, whatever. So F in, filter in. Filter in, and then that goes to there as well. That's going to be hard to see in the future, but whatever. At least it's on an isolated layer that I could turn off. So that goes to the filter in switch. Where does this one go? Pin 2. Because remember, this is our oops, wait. Yeah, we'll just keep that. This is right here is where our signal's coming in. That capacitor, our signal's coming in there. It comes in there, doot, doot, and then it goes off to the switch, and then it comes back from the switch. Or no, sorry, that's where it comes back from the switch. Right. This is where it originates, but then it goes to, so our two signals or two waveforms coming in here through the capacitor before the resistor and after the resistor. So that is a, wow, 100, that's a 100 kilo ohm resistor. That's big. That floating thing, something tells me that that is a cab, that there's a cab somewhere that's unhappy. Floating thing? What, huh? Oh, the floating via? It's so weird, that floating via, but it basically indicates to me that there was a design revision. You know, they had some signal that had to go through, where is it again? If we find it. You know, like this area right here is what it probably looked like before. But then, you know, something got revised and I don't have to run this through here anymore. So you end up with just like a weird orphaned via. Down and around. Yeah, this right here. There's probably a signal that went through there. I think that's what he's talking. We could be talking about something else. But yeah, so the only thing between these two is this input. And our signal is still kind of pathetic right here. So on the other side of the 100K, what does our signal look like? That looks pretty good. I guess that's the effect of the 100K. Where are you going from here? Because, like, once we get out to here, to the filter, which one of y'all is the filter? There it is. It's pathetic. It's out of spec. But wait a minute. So okay, here's what, okay, I think I understand now. I understand now, and we've been beating around the bush with something that is not an error. We got to remember that the TB303, the Roland 303, was using this signal internally. So it takes it as it is. It just uses it as it is internally. Whereas the M303 can take in an external audio signal and apply the penis ladder filter to it. There's the diode ladder filter. So we can take an external signal and apply a diode ladder filter. We need an external signal to go into the next stage. Why don't we also output that external signal? So the capacitor and the resistor is turning our internal signal into an external signal because that allows us to do all that routing for modular synthesis. So they've taken what Acid Labs has done is they've taken the stages of the TB303 and they've created them in faith, but then they have taken them so that they can be plugged in externally. They've exposed them to the outside world, and in order to do that, you need to get it into the right ranges. You don't want to have a 5-volt offset on a signal that you're outputting. So that means that your available signals in would either be that offset signal and a normal signal, or your normal signal and your normal signal. So now they're taking the two normal signals in. So everything is in spec. We are not supposed to look like these signals after that capacitor. Before the capacitor, fine. After the capacitor, no. It should look like a normal outputting signal. That still doesn't allow for whatever the hell this is. Like a package is being delivered. I had to order a bunch of fire extinguishers. That doesn't account for this like negative voltage offset that we get from the sawtooth. That shouldn't look like that. So there's still an error there. That should look like a normal audio signal. That should look more like this once it settles. So something funky is going on there. But as far as we're concerned, everything, well, on the square wave, everything before the switch is working, and some of the stuff after. Everything all the way up to the filter, even the input to the filter should be acceptable. So it eventually settles onto the right thing, which is probably its own issue, but that sawtooth should not be negative. Yeah, let's center this again. So yeah, those are exactly the same, and then I flip the switch. Oh, they're still exactly the same. So it doesn't matter which one we're looking at. It's funny, that should match the output. Maybe before the resistor is where they're headed. Oh, you know what it is? That resistor's there to isolate. No, that doesn't make any sense. Why would that resistor be there? Well, where's that second pin going? Let's trace that out real quick. So with this plugged in like this, our other trace is this one. That should at least look like some. Did this just turn off? What happened? I moved and it undid. Power must have moved or something. Almost very familiar. So that one goes possibly right here. Yeah, so that's where output is. So VCO out. So mark it down. If we're getting new information, we need to mark it down. And of course, I've painted myself into a corner here. Cool, totally easy to read. Control S. So filter in and VCO out. When you plug into filter in, what you're doing is you're cutting off this line right here, but you can still use VCO out. So you can send it to some other filter and then have it come back into your M303 or any other number of combination of connections. So when you're plugging into filter in, you're not totally cutting off your VCO from doing anything. The VCO still functions and can still send signals elsewhere. So far, everything we've seen is pretty logical and sensible and works. So maybe there isn't so much of a problem with the OG signals, huh? There still is some problem with that triangle wave, but it's kind of out of spec. It seems like it needs some sort of an offset. So what's the status of this 10K resistor? Because we've got a circuit here that eventually goes down to a comparator. This will be like that, like that, and then it outputs here. You got a resistor there, you got a feedback resistor. Here we have spikes, and then here we have our sawtooth. But it seems like, I don't know, maybe the offset's off, or this offset's off. This still does seem to be making current spikes over here. It might be this part of the circuit that's gone wrong in order to make our sawtooth funky. And I think the big contender here, I think the big issue might be this component. It might be this component, but we don't know for sure. Because it's still doing stuff. It still functions just fine. Like that sawtooth looks okay on the output. But when we test it over here. Whoa, hold on, what's going on there? Should be channel 1. Oh, I'm on X10. Wait a minute, what? Channel settings. Bring up channel 1 menu. How do I do that? No, wait, that's horizontal. No, that's not right. Oh, there it is. No, bring that back. No, what are you doing? It just dropped it. Turn it on. Pull up the menu. Pull up the menu. There it is. Jeez. Scale 2 volt, offset, blah, 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 and blah, 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 bandwidth level label, blah, 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 blah. Yeah, so that should be fine. Oh man, there's a lot of weird stuff you can do with this scope. Label off, invert off, unit volt, coupling DC, bias is 0, bandwidth limit off, channel skew is 0. Okay, so this is all set up. I don't know, this thing has been on X10. Does that mean all of our signals have been stupid weak? And I've been seeing the wrong numbers out of everything? It's funny, testing that one messes up our output. Ugh. I think this thing is set up for 10 times. I don't see where the setting is, though. I thought I had it on 1x, but I must have it on 10x mode. Strange. That's always a little weird. Oh, what is going on there? What the fuck is going on? What's going on? I'm so confused all the time. Okay, hold on. We'll rein this in. Somebody keeps setting off the door motion sensor. I have those for when I'm alone in the house. That should not look like that. Okay, so it is 1x. I don't know why everything is all messed up. This should look just like our output signal. Yeah, it does. Why is our output signal? I guess that's centered around 0, but it's not. It's offset a little bit here, but it needs to be offset. No, I guess that's correct. That is correct, because our triangle wave output is between 2 volts and -2 volts, which apparently is, you know, typical audio in a synthesizer. The square wave starts off in a weird spot and will eventually get down to the right spot. I don't know where that offset is coming from in the first place, but it gets there when it gets there. And so that is correct, and that's sort of within spec then. If we trace it back further beyond the capacitor, we do actually get an in-spec wave for this one. The triangle wave, we don't. We get just kind of a weird... We don't get the full offset, but I don't think we need to, because we're not sending those waves to the filter. Those don't go... Yeah. Triangle wave man hates person wave man. They have a fight. Triangle wins. Triangle man. Triangle wave man. I have all that stuff memorized. So there's a triangle wave that looks like the right thing. Maybe we just haven't been probing it in the right spot. And the thing is, it doesn't matter, because of the fact that this is a modular synthesizer, Acid Labs took these into normal voltage levels, and they took them from positive to -2 volt levels. And we can observe them centered around the number line on their positive to -2 volt levels right here, which is where it outputs. But then instead of routing those offset voltage waves, instead of sending those to the transistor ladder filter, instead we have a 10K right here. And I guess the 10K is to keep this from influencing an external signal or something. But then this'll cut it off. This'll cut it off. I don't know why that 10K is there. It's weird. So the 10K is just kind of tamping it down a little bit. I guess it's a current limiting thing. Maybe it helps prevent feedback, because this part of the circuit where the wave is here, right here, that goes to an audio connector that can cut it off. So this part right here, this goes to an audio connector that you can output from. It doesn't cut it off. This right here goes to an audio connector that can cut off the wave. And it comes back over here on this pin. And so it comes back from that connector. Looks like it's a little worse for its wear because of that 100K. And then it weaves its way circuitously around the board until it reaches the transistor ladder filter, which is this structure right here. You can tell because of the way it is, because that'd be like it do. And so this is where it gets kind of a frequency-dependent, voltage-operated cutoff. And it goes through a 120K resistor. And I feel like it shouldn't look so pathetic after the 120K, but I guess it does, for some reason. And apparently it's still there, it's just very weak. So what did we do just now? I lost you 3 this here back, and then I said, you guys got to make a little bit more sense. I don't know what's going on with you guys. Oro sad. Oh, you lost 3 this here does X. Here's the deal. Our signal is being created. Our waves are being created, and we can verify that the proper waves are being created in the circuit. They're being created in the same way that the TB303 does. The original 303 does. There is the added stipulation that these signals also have to be output to a modular rack system. So we see these signals being turned into modular rack voltage levels, right? And then it comes back from that stuff where we can cut it off by plugging in a cable, right? That's all the in and out stuff. What are you banning weird people now? What was that? Did I miss something? Waves are synthesized. They're put into the appropriate voltage levels. They can be put out, whatever, doesn't matter. Then they go into the filter at those appropriate voltage levels. And that's okay. That's something that can be done. One from earlier going back to check that it wasn't a regular user. Oh, you don't have to do that, Gonad. I appreciate it, but it's not like, you know, you don't have any obligations. Because I certainly don't do it for your channel. I guess if I saw it, I probably would. I would if I saw it. I'm looking at the PCB right now and just sort of scrolling around on it. So that leaves us with the filter. We've pretty much cemented that our oscillators are working just fine. So all this business over here doing the oscillation, that's all fine. This is all working just fine. It's now this stuff right here, this ladder filter, that is at fault. So we're literally back where we were at the beginning of the stream. It's just, I understand the ladder filter a little bit more now, but I feel like that 100K should probably have more punch to it. I feel like we should probably be seeing a normal signal on the other side of this. This is where we get into the structure over here and the actual ladder filter stuff that we did do a little bit of follow along schematic with, where I was writing down what all the stuff did. And I don't know, we didn't get very far, but it does look like a normal ladder filter. And so from there, I'm wondering what exactly I can glean from this. Now, are we making progress? Yes, I think yes. It's not fast. It's not going quickly. This is where I kind of run into my whole philosophy on this stream is to show it like it really is, because it be like it do. You know, we keep it real in here, and keeping it real unfortunately means that sometimes we get bogged down in a project. We haven't visited this project in a while. What we did do is we made sure that we know that our oscillating section works perfectly. So the original broken part of the synthesizer is fixed. Now we have to fix the part that I broke. And so we've got a filter to go through, we have an amplifier to go through. That's where we are with this. And that's where we're going to discover how this thing, you know, works in a little bit better. But we know that the oscillation part works. I don't know how that works. I need to look up like how that is designed. There's probably a Moritz Klein video that'll properly explain the excitation of transistors and stuff. But yeah, at the very least, we have a device that is producing wibbling waves. Now, when I look at the output, if I put this all the way on the output, we probably don't get anything, right? So our full output is here. And we take the resonance and all that stuff. Yeah, there's just nothing going on in the output. Yeah, so there's still stuff broken. It's definitely not working. We would be getting something out of this thing. This is just the most frustrating. It's so frustrating. So the output of the diode ladder filter, I like calling it the penis ladder filter because it looks like this. Now let's be real here, right? This is what the filter structure looks like. That's a penis. It's a penis. It's a penis ladder filter. Come on. You can't sit there and tell me that that's not what you're seeing here. We're at the input of the filter. If we look at the output of the filter, it will be a differential that is across nearly the last stage. It's 3 like that, and then you've got the ones that are coupled to positive power. So we're looking right before that, and we're looking across the capacitor. It would need a trigger to output the out. Oh, because it goes through the, whatever it is, ADSR or whatever. We have given it triggers in the past, but what we should be seeing is before the final 2, this is 1, 2, 3, 4, 5, 6. 2 at the bottom, 3 in the middle, and then 2 at the top. It'll be across this capacitor. We should be seeing a waveform in differential. And I'm just seeing 12 volts on either side of it. Hold on, now that I have a mouse again. We fixed my mouse in the middle of the stream. How's that for yak shaving? Yeah, you're right about the trigger out, but I should be seeing like a differential on these. And maybe it's so sensitive that maybe I need like a... I can do a channel-to-channel differential. Let me get another probe. Channel to channel. Differential. Activate. Let's see here. So I get this, and I plug this in over here, and then I say, hey, channel 3, let me see what you're doing. And then I go to math, and then I go, that's the math menu? Ah, Jesus, okay, hold on. I gotta lean in with my magnifying glass. Math 1, operator. A plus B, I think, is just fine. Grid, full, scale, 500 millivolt. I don't know, we'll leave it on that. Source A, channel 1. Source B, channel 3. Okay, there's our math. So, let's math it out. That's the power of math. Whoa, science! All right, hold on. I hate that kind of stuff. Sounded like a Power Ranger. Yeah. I'm just being stupid. This is how I entertain myself while I do this. Yeah, there's no difference between them. They're just sitting up at 15 volts. I was hoping we'd get like a millivolt difference, but... Celia Russell! Subbing with a tier 1 sub for 80 months! Oh my god, what is this link? Hold on. It's gonna be something stupid, isn't it? You know, there's nothing more compelling than the perfect shaped stick. Why would okay, it's A plus B. We need an actual differential, that's right. So would be A over B? No, it would be differential. Well, A plus wouldn't be it. A minus wouldn't be it. It would be like difference, ABS low pass, integer, no, diff. There it is. There we go. Okay, now we're doing the proper function. Because there's no difference between two signals at 15 volts, like, you know, whatever. So across this capacitor should be the output for the filter. It's nothing. Why would it be so positive? Oh, I see it crossing. It shouldn't be 6 volts, though. I think there's a vertical component in there. How do I change the scale of math? Oh, that doesn't. Okay. Go to 15 volts and see what we get. Okay. Why? The one signal is at 15. The other signal's at 15. Oh, is that one at ground? Go back one stage. They're not positive and negative. Oh, I guess that's not the math menu that we're looking at. Okay. But math is on, right? It's not. Turn it on. There we go. That's more like it. Technology. Huh? Whoa, what is that voltage scale? Oh, is that doing a... I think that's doing a... Is it doing an integrate? No, it's doing a diff. Well, differential. Well, that's not the differential that I'm thinking it is. Shouldn't the differential be coming up with the right stuff? I should be getting some kind of a diff. I think I'm thinking of it in the wrong way. Shouldn't the differential be 0? No, because that's a function of time. No, it's doing a different math operation than I wanted it to. No, I need a voltage differential. I need a VDiff, which would be A to the B? No. Absolute value? No. A times? No, that's not it. A plus. A divided by B? No. Low pass, high pass, band pass, fast Fourier, square root, log. Would it be ABS be the right one? I don't think that's going to be right. Oh, and then we have that FFT window open. How do I close you? Get out of here, FFT. I don't need you open. I guess that is the math menu no matter what. Math there. Oh, I see. ABS only takes one input. Oh, so does differential. I see. Like, it would be 15 minus 15. I guess we'll try that. Channel 1 and channel 3. So 15 minus 15 in millivolt. Then I go across the capacitor. It doesn't even show me 0. It just goes all the way up. Try these. First stage. Oh, you two. I can't win this one. Resolutions too, it's way too tight. How do I up the resolution on that? Math. Menu. I guess I can do it through the menus. Why is that offset? 0. Millivolt. And then scale. Oh my god. I'm doing each one at a time. 2 volt, 5 volt, 10 volt scale. There. Jeez. Okay. Less noise, more signal. Okay, so it is functioning properly. So the offset is like weird. It's not, I'm not getting a waveform on there, but it is in volts. So let's bring that back in to volts using this little button right here. 100, 200 volts. No, we're going the wrong way. We're going the wrong way. I don't have that many capacitors in the shop. One of the big things about the repair analog, how to repair analog circuits book is Bob P's made special consideration to tell you about capacitors. If you have a capacitor that is the size of a shotgun shell, it has the energy of a shotgun shell, and you need to be extremely cautious around it. That still does not strike me as a waveform. We should have a differential across the caps that give us our waveform. Reminder, our waveform looks like this. Should look like, hold on. Why don't we have a waveform? Where's my waveform? What happened to it? Waveform. It looks like that. That's our waveform. I just don't know why this output's not giving us... Oh, because I switched it. There. We should be getting a waveform that looks roughly like that. Oh my god, the differential. As I touch, I am a being of pure ground. I am grounded in many strange ways. So A minus B is this. If I do it the other way around, it's the same thing. There's no evidence of a waveform in there. The shotgun shell analogy. I mean, you know, he's talking about how powerful they are, but you don't want to mess with caps. It's not coming out of the filter intact. I don't even think it's going into the filter intact. This is what it looks like when it goes into the filter. This is just a positive wave, the positive voltage level at 5.3 volts. So that 5.3 volts is supposed to be mixing with this thing in order to give it an offset. I think that's probably what they're doing. They're putting it back in and offsetting it again. So something is going on. It might be one of these transistors out here, perhaps. But this is where the two circuits differentiate from one another, I guess. So more research is called for. Our waveform is coming in just fine over here, but remember it's not shifted into audio level, or shifted from audio levels. Yeah, you got a bit of a delay there because I figured that one out pretty quickly. You can see how long it takes your text to go on screen. Am I super? I shouldn't be. I'm not super delayed. I'm real time, mofo. My bitrate is. It's okay. It's doing all right. I need to get back to uploading YouTube too. I still have 100 videos to go through. I think I'm going to take a break for just a little bit, and then we'll do that last 100 in a big push, because it's really grating on my ability to work on stuff like this in the background and do things like read that book. So there's going to be an extra circuit structure after this 220K resistor. It's going to be something that'll shift our signal back maybe into the realm where it was on the TB303. So like shift it up 5 volts. Yeah, that YouTube delay is pretty crazy. Better player, but people can tend to get way more delayed depending on, like what's going on. Okay. So I guess we get into territory unknown in this case. This is where we're going to have to start kind of looking through the what circuit is actually here instead of what's in the schematic. Now I do have our notes from the other day. Where did I put them? They are... Where's my notebook? There it is. Hop, 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 hop. Ah! So, I can close the math menu. Boop. Actually, take the scope off for now because we're in parts unknown now. Now I need to actually verify what's here on the circuit and what the circuit actually looks like. Now we did do a significant amount of tracing, so we do know that this is what's there. It looks like what we're doing is, and this could be laid out better. I would need to do a couple revisions, but we have our signals coming in. So these are plus minus 2 volt audio. And then there's actually like a cutoff on that, but it's like we have the waveforms coming in and going through the FN jack. And then, well, it's like 100K VCO out. And then we have audio, so waveforms. Oh yeah, we have that switch, stupid switch. Select. Have our triangle and square. There. I'm calling it triangle. I'm going to keep calling it triangle. I'll never stop. I can't seem to pronounce the right name. I'm so sorry. That goes to there. Plus minus 2 volt audio, right? So let's just, I mean, this is a sloppy schematic. I'm not going to redraw it right now, but we come from this switch and we verified this works. So we know this works. It just takes a little bit of warm up when the thing starts up. So our audio waves are being selected by the switch. They go through and potentially out of the whole synthesizer, which is why it's important that they're at plus and minus 2 volts. Then they go through this frequency input thing where if we plug in an external signal, it'll cut it off, right? So then that signal gets routed into the 120k ohm resistor and the capacitor that normalizes it, basically, that puts it on the number line. My only problem is right here, there's nothing. In the original filter, TB303 has something like a 5-volt offset. And then, let's see, it would be 5-volt offset, and then is the from -2 to +2. So we've got like 4 volts there, 5, 6, 7, 8, 9. That seems about right. So 5-volt offset, and then 4-volt plus minus 4-volt, or no, plus minus 2-volt. So pretty much putting a 5.3-volt offset, which is what this is here, back into here will bright things again. And I guess that's kind of what they're doing here. It just seems a little weird. It looks more like the function of, this looks more like the thing from the diode ladder circuit. So it seems like maybe they're just taking that normal audio level and applying that to their filter. And then at the end of the filter, at that last capacitor, it goes out and into a bespoke differential amplifier with its own sort of like Darlington stage at the end. That's sort of what we've been able to trace out so far. There's a lot of controls in here. So there's a lot of stuff that gets controlled. This is where you get your resonance and stuff like that. I don't understand then why we're losing the signal right here. Because here you would expect it to be, well, offset or something. Could it be possible that these transistors rather are dead? If those are dead and we're syncing it to something, maybe that's why everything goes nuts. Gremlins, yeah, probably. It's probably gremlins. I don't know, man. Yeah, so I'm not seeing what I should be seeing right here. I don't think it's this capacitor. We tested it and we got 1 up out of the cap. I don't think it's the resistor, because I can test from 2 separate areas, and that means that I'm testing the circuit and the traces all the way up and through the 120 kilo ohm resistor. I'm going to get a glass of water and think about what I've done. Let's see. Where's BRB? Setup. No, not setup. Overlay. Nah, it still works. That's nice. Yeah, I'll be back in just a second. I'm just going to get a big old glass of water and use the bathroom. Celia gifting a sub to Web TV Live 108 times. Holy crap. Thank you so much, Celia. Well, at least my Stream Deck stuff still works. I don't know what song that was playing. I'm sorry. What am I looking at? Failure. 2 months of failure. 3, 4. I don't know how long we've been working on this thing. Yeah, it's been bad. I'm drinking a little bit of water because my voice is getting scratchy. The water from the tap is coming in warm. My morning shower feels like it's like 5,000 degrees. Oh, it's terrible. So we've been reverse engineering this circuit. We are at the stage because this thing goes. What do we got? It's hold on. I'll set this up. Need a big marker for this. So we got a couple blocks here to this thing. VCO. We've got a VCF. What's after that? Is VCA? Council pop? It's towards the bottom there. How far up? I don't know. I don't recognize it. Okay. So it goes VCF into VCA. And then envelope. Yeah. VCO, VCF, VCA, envelope. Let me double check that. There it is. VCO, VCA, VCO. Mono, multi, mixer. Okay. Ladder, amplifier, VCA. Okay. Voltage. Where's all the V? It comes from various places. So VCO, VCF, VCA. So we have proven out this. That's where we are. The voltage controlled oscillator works, all save for the tuning of it. That works. We don't know what's going on with the VCF. I have traced perfect audio coming out of this thing. Plus, minus 2 volt audio. Right there. So, this works. VCF, the VCA, possibly envelope. Or not, that's not envelope, it's I don't know what to call that. I guess part of the part of that is their gate trigger accent. Yeah, so this would be where the gating happens in the VCA. So like, okay, we know this works. We don't know if the filter works. Now I've tested at the end of the filter. I don't get bupkis. There's nothing happening. We know the filter looks a little bit like this. This is not the whole thing. It's some of it. There's a transistor ladder. There's an output from the transistor ladder that goes into a differential amplifier. That's part of a normal transistor ladder filter. When I probe over here, I get like nothing. I get nothing. And I did a differential probe. I did A minus B. I mean, something over here is dead. So I went all the way to the beginning. where our plus minus 2 volt audio is hanging out on the traces of the board. We got to this 120 kilo ohm resistor. We tested on the other side of the 120 kilo ohm resistor and we got nothing. Well, did we? Wait. Yeah, we got pretty much nothing. There's a millivolt signal there. Now that's actually supposed to be there. I guess that's what's supposed to be there. Because, I don't know, it just has something to do with the way that this thing functions. Through the capacitor, that nothing signal is then located on the number line, and I don't understand why such degradation of the signal can happen and it can still function properly. But it's not the audio coming in. That's not the problem. Something is happening here that I don't understand, because this is a very difficult to understand filter. I saw a breakdown of these things into equations, and it was not pretty. Bum, 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 bum. Fucking Dinsdale. Dins, you got the theme to Gremlins stuck in my head. No, we managed to keep the magic smoke in, but it's possible that this area is where all of my problems have stemmed. Like, it's possible I caused all the problems that we're trying to solve right now. Bum, 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 bum. Odd the signal is that low after the resistor. Yes and no, because what I read is that it's supposed to be very low after that resistor. And maybe I need to go over that document again. You probe around the transistors and just see on what pins you have the signal and what pins you don't. No, because it disappears at that point. It vanishes as soon as it gets into the filters. Once we get to the other side of this capacitor, there's nothing. It does nothing. It's also strange to me that the capacitor is facing in this direction. I don't know why it's facing that direction. So if I do like ladder filter probe, there's all kinds of information about this stuff. But, you know, see here, talks about how it works. I probably need to read up on some different designs. The document that I found was like perfect. It has 3 different kinds of filters in it that it studies. And it goes through all of the equations and stuff. There's also this all about circuits one, but that one's not as detailed. But there's a couple different topologies. One of them involves these resistors on the side. We don't have that kind. We don't have this kind either, where the bases are connected across transistors. That's not the type that we have. We have the Moog ladder filter, which involves a pop-up. But yeah, 3 stages make up these ladder filters. We got the driver, where our current bias is coming from. So that's what all that circuitry is that sits below the thing, is biasing. And then you have your input and your feedback. And so the resonance controls how much is feeding back into that other transistor. And this one works a little bit differently because it's, yeah, anyway. And then, yeah, there are our clusters are basically voltage controlled thingamajigs. And this would be the, what is that? That's the Dyer, what is that? Yeah. My understanding of this is very bad. So this is what I was reading, is a lot of, this All About Circuits thing I think stems from that other document. Somebody did like a full analysis document on it that had all the equations and stuff. The Moog is one with the resistors. No. I don't think so. Wait, maybe it is. We don't have those resistors on this. Not on this design. But are bases connected together? Ours are the ones that loop the transistors in order to use them like diodes, because they're apparently better matched diodes. No, it was that PDF document. Let me find it. It's in Discord. I can open up that document. Find it. Dun 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 dun. God damn you, Dins. Why did you do that to me? I haven't watched that movie in years. If I Google Moog, I might find it. We're still in server era. So before server era, the server stuff I'm still working on. It's taking me a long time to figure out. I'm getting there, but it's just very slow. Oh, that was the window that I wanted. I don't want to open Discord on stream. I want to just I'm trying to find my link. My stream projects section has gotten quite chatty. Quite chatty. I don't need those chats in there. I need it to stay a little bit more focused. Here it is. Moog ladder filter. So if you're looking for this document, timstingcomb.co.uk/synth/moog_ladder_the fuck.pdf. Analysis of Moog. Analysis of the. I can read. Analysis of the Moog transistor ladder and derivative filters from 2008. This is a very good document. It's very nice and neat and organized. Now, this took a while for me to get through, and I read the whole thing, and I still don't really understand a lot of it. So I need to go back through and read it again because it is very technical. But he goes through like full analyses in order to give you transfer functions at the end, and sort of what they bring to the table. But the differences in designs, the base circuit of the Moog ladder transistor filter, I guess there are resistors on it, but there are different implementations. So the core and stage numbering. So this should be essentially what we have. But there are variations. And so he actually goes into some of the variations after we get through this. So this one is a simulation circuit. Oh. Yes, wonderful, wonderful, wonderful stuff. A lot of science going on here. So here are the variations in the diode ladder filters and the alternative designs with the transistor ladder filters. Where are they? Hold on a sec. Is this all of them? Whoa. This is the type of filter that we have. This right here. Simulation circuit for the TV303 type. Well, the thing is, like, even though this is the simulation circuit, this very much resembles what we have. Oh, TB303 was there? Okay, yeah, let's go back to that. Yeah, we're very much a TB303. And these all have different characteristics. They all have different sounds. They all have different behavior. Diode ladder and stage numbering. More diode cores. Various diode. Is one of these count as the TB? Let's Control F. Firstly, we note that there are a varying number of diodes at the top of the ladder. With one diode, the Roland TB303. Okay, so it's a transistor, but analytically, it's the same as if it were a diode. So the TB303 is up here. Or no, down? It's down. Down for the figures, yeah. So there it is, TB303. Oh, it was labeled right next to it. I didn't look. I know. I didn't look at the labels on the sides, the ladders. Yeah, so the TB303 is the transistor stage at the top, and then, yeah, four resistors. Sorry, four capacitors. We've been through a lot today. I fixed my mouse. So our input and our resonance input come in at the bottom of the ladder there, and they're filtered up through the stages. And then out of the output, we have a differential across the 33 nanofarad capacitor. When I looked at the differential across that thing, it wasn't there. So our diodes are fucked. And by that I mean our transistors, I think. That means getting out the multimeter and seeing if we can trace down any broken, like if, yeah, listen, don't correct me in the moment. I'm not really that out of it. We've just been through a lot today. I had a lot of spicy noodles for lunch. That kind of woke me up. These have been like a thorn in my side though this whole time. It would be nice if we could get the signal through this mess and figure out what exactly is going on here. So we're in the heart of the circuit. We're in the middle of the 303. I think it's down to doing a little bit of diode testing in order to figure out whether or not the filter stuff is working. Now, I do know what we can do. Well, no, we don't need to. I was going to say, like, we can inject our own audio signal into the filter, but we don't need to do that. I don't need to do that because we know that our VCO works. We got a plus minus 2 volt audio signal to a T. That's exactly where it should be. So we know it's getting fed. And if I plug in, I know where my signal is going to go into that filter and then die. It is another data point, though. It's another data point. Where did my thing go? Where did my... That's the Bringo. Where did my voltage, my frequency maker? Where did that go? Where did it go? Where's it? Where'd it go? Hello? That's probably in the cabinet where it belongs. Or it's not in the cabinet where it belongs. That's where it belongs, right there. Curious. Disassembly by CNC. What is stopping us from figuring out if it's wrong? No, nothing's stopping us. We're continuing. We are continuing to move forward in proving out. What we've done today is we proved out that the oscillator works just fine. The voltage controlled oscillator is doing what it should do, and the signals going in and out of it are correct. We don't know what the signals inside of the oscillator, the signals inside of the filter should look like. So my probing inside of the filter is sort of an exercise in question marks. It's not really going to tell us anything too definitive unless I knew exactly what my voltage signals should look like, which I don't. So I'm looking for my frequency generator so that I can generate a frequency and throw it into this device, because we know now that if we plug into the audio input, we are putting audio into that filter, and we can see if we get anything different than when we use the internal signals. And if we do, then that's a big question mark. That's a big question mark that I don't know where it's going. Where did my frequency generator go, though? I got this little DIY kit a long time ago. Should have gotten two. Put it together, and it makes all these wonderful little frequencies that I can use to test stuff with. And it previously had a... Oh, I see, it fell behind. Okay, it's still there. It's still there. Filter is made of multiple components, and probing inside of the filter won't help, as you know what the signal should even look like once. Yeah, we know what it looks like now when it enters the filter and why it looks like it does. Why it looks like a simple 2-volt audio signal. And the reason is because this is a modular synthesizer, and so at this stage, you may have to input, you may want to route it to something else. You know, modular synthesizers are like that. You could just, oh, I want to put my own filter over here. So you could do that with your VCO, right? And then you could bring a signal back in and put that in. And so that's what we're going to do. We're bringing a signal back in, and we're going to put that in our VCF in. 1, 2, 3. So that's here. We don't need VCO control voltage on this. That's just, we're just taking it at face value. We're not giving it a control voltage for that. That needs to be tuned eventually. If the signal dies on a diode, it works all right. Yeah, it's a livode. It gets a hard node. Okay, so plus minus 2 volt sine wave. Let's see if we can get that out of this. This thing, it's not super simple to program. I could use maybe other signal generators, but that signal generator that was sent in, I should really fix. So 1 hertz square, let's do like a 2 kilohertz. Oh, I didn't tell it. Frequency 2000 hertz. 2 kilohertz, and then not 10 volts. So an amplitude, I want it to be 2 volt. Oh, whoops. Amplitude. Amplitude 2 volt. Actually, no. Amplitude would be 4 volts, and then offset would be minus 2 volts. Okay, 2 kilohertz square wave, 4 volt offset. We can observe that when it gets in there. Sorry, 4 volts, and then let's change the waveform. So ramp, user, sine wave. So we have a 2 kilohertz sine wave that is at 4 volts. So it's 4 volt max, offset by -2, plus minus 2 volts. So if I plug that into the filter input, and then I check what's going into here. Oh, turn the scope back on. Scope, bonk. There's our 2 kilohertz sine wave. Is that channel 1? Center. Why is that negative? Why is that negative? That should not be negative 4 volts. Oh, it's like dead when it gets to the other side of that. And it's just dead. That should be -2 volt sine wave. Man, why is this frequency generator messing with me? I've had enough of your bullshit. Huh, guess I can't really do anything about that. Why would it be negative? I said -2 volt offset here. I don't know how this thing creates its voltages, but usually we're in good shape. Why would that swing it all the way down? 4 volt, offset 2 volt. What if I do amplitude 2 volt? Volt, offset of 0. Why does this thing never take the first instruction? Offset 0 volts. There we go. Take a look at what that looks like as it goes into the next stage. Oh, look, it's a 1 volt. So does this need to be 4 volt 0? Okay, I get it. All right, so it's AC coupled. Amplitude 4 volt. Amplitude 4 volt, you stupid machine. There we go. Okay, so now this should be our plus minus 2 volt audio signal. Bada bing. Okay, so we've got a slightly higher frequency wave than what this thing is dealing with. But then on the other side of the cap, we get nothing. This side of the cap, we get nothing but a millivolt signal, which is apparently what should happen, but I mean, if I put a signal like that through a resistor, Yeah, I was assuming that this thing was DC because it has a DC power supply that goes into it. I was assuming that was how it was treating it, but it's treating it as a positive and negative system. You get it mixed up when you go DC to AC. Weird. And like I can take it down to 1 kilohertz, it's not going to do anything. There, 1 kilohertz sine wave. Kilohertz. There's a 1 kilohertz sine wave. It's coming from here. And it's not going to be what we see over here, but it will be what we see here. No, we don't see that there. We don't see it here. We see that there. That's the offset one. That again. There's a triangle wave. That's the switched output. But that doesn't matter because now over here on the input to the filter, we have our 1 kilohertz sine wave. So we have our sine wave. We can eat it too. Go through the 120 kilo ohm resistor and it drops down to like almost nothing. But that's fine. That should still be functional. We get rid of a DC component with that capacitor. After the cap, we have this oh, I see. So the DC component is blocking the return path. It's keeping this DC element from getting back over here. And this DC element is bumping us up to 5.3 volts. So we have our millivolt level signal after the 120 kilo ohm, and then we have a re-injection of the 5.3 volts into the signal to offset it as if it were the Moog. Because that's where it should be in order to function in the TB303. So in order to make it like it was the Moog, it's offsetting it at that juncture, which is for some reason here. And this very much resembles what we've seen in the circuit. We have a 5.3 volt thing going in here. What is that? I mean, but then this one's already offset. What the heck? There's a lot going on here that I don't think I fully understand. I don't think I really fully understand. Which is why I need to read up on the filter a little bit more, because it's like we're not seeing the signals that I think we should be seeing. Especially where there's no evidence of a sine wave here. I was thinking that maybe we're zoomed so far out on the scope that it could be possible that there would be a sine wave there, but I did evaluate the differential using the scope, and it saw nothing. So if I put this into differential mode, I turn my math menu on, and I do A minus B. See that it's chaos. If I touch probes, I have a little sword fight with my probes. We can see that there's like, it's just noise. I give noise on one signal, it'll of course show us noise. Noise on the other end. That should probably cancel out the noise, but it didn't. But if we look at the differential, noise. One stage back, still noise, which is odd because there's no output from that filter. After the capacitors. Yeah, it seems like there is this nothing. Might mean that the transistors are bad. I'm wondering if those 3 components in there are bad, or if it's the big cluster of transistors that's gone, you know, gone funky, which may be the case. I think I'm going to wrap it up because I'm starting to really kind of feel it. I'm getting very mad at the circuit. I think what I need to do is look a little further inside myself, really evaluate who I am as a person, and figure out how to fix this fucking thing. I'm thinking it's probably the things that we already have extras of, right? Those transistor, multi-transistor clusters. I don't see why that would have gone wrong, but if we plug the thing in upside down, it's likely that some voltage went to the wrong places. You know, maybe some differentials went into the wrong ends, and everything got mad. So I am going to maybe look at those transistors individually tomorrow. We can do some diode testing on them to see if they come out properly. We can see if we can get this thing running, or we'll spend another day just faffing around like we did today. At least I fixed my mouse. You know, that scroll wheel problem won't come up for another couple of years. I got the mouse in, this one I didn't get in 2020. Actually, let me see exactly when I bought this one. Let me see when I bought this one. It was the Rival 610 that I got in 2020. Mouse. If I could move the cameras into the other part of the basement, I would love to do a stream where we put together a 3D printing area. Rival 310. This mouse is from 2018. 2018 I bought this mouse. So it's been doing pretty good. I don't know how much I got from it, or I bought it for. Yeah, they don't have one. Nobody has them anymore. The Sensei is $310. Holy shit. Oh no, it's 68 bucks. Never mind. Weird. Okay, anyway, yeah, I'm gonna shut this stuff down. It's gonna take me twice as long as normal. And then maybe I'll do some server stuff in the near future. We got a lot of projects that are kind of hinged on me getting the server running again, which includes burn the subs, because once I get Node-RED functioning, we need to work on getting Node-RED working with Twitch. It's already working with OBS. I have to get all the things back in place that make it do that. So I'm going to think about doing that. Maybe that's what we do tomorrow. Who knows? I like doing this stuff, though. I like doing the circuit work. No Node-RED working. It's back on as an application on the server. So it's now an application on the server, but I need to get the MQTT broker running again in order to get Node-RED functioning. And then we can try to get Twitch into Node-RED, and that'll give us that extra layer of connectivity. We go back into the microcontroller code for the fart box, and we give it some like HTML triggers or whatever, or HTTP triggers or whatever. We need to figure out how we're sending those triggers into it to do a fart. But that opens up this whole world of interactivity. So yeah, configuring stupid stuff is all home automation's fun. I don't know. I like Node-RED over Home Assistant because Node-RED is not meant for home automation, so you get so much more functionality than you think you'd need. All right, anyway, thank you. Yeah, thank you guys. Thank you for joining me on this journey. It's been very frustrating. We made a little bit of progress. Those little bits of progress will eventually get us to the goal. It's just the bite sizes are getting smaller and smaller until we get to our solution. Hopefully it'll present itself soon. We haven't seen evidence of that yet. So we either work on the circuit tomorrow or node stuff tomorrow. We'll see what goes on. I'll be back tomorrow. We'll work on cool circuit stuff. I got it running. I need to dig in and figure out all out. Plugins are awesome. Seems simple enough so far. Yeah, that's what, and I'm using apps in TrueNas, and so it's working pretty good. All I need is that MQTT broker, and I don't know why they haven't done that in the TrueNas server, but I'll figure it out. Anyway, here's the end card. This is where you can find me. I'll be on this stuff in between when I'm, that's Discord seems to be like the only social media that I'm looking at lately. It's getting bad out there, guys. I'm participating in anyway. So you can put Node-RED inside Home Assistant. I don't want to do that. It's weird. No, I'm not doing that. Why is it all so circuitous and complicated and fractal? I don't understand. This Linux stuff is like, oh, just use it. It's so simple. Nothing will ever go